Welcome to Quiet Universe, where the deep mysteries of our planet unfold in ways you've never imagined. Today, we venture into a realm few have dared to explore, a world so vast, it stretches across the ocean floor in quiet solitude, abyssal plains. These immense, seemingly endless deserts of the deep sea are some of the least explored, yet most critical regions on Earth. Here, life persists under crushing pressures, in frigid darkness, far removed from the warmth and light of the surface. In this journey, we'll unravel the secrets of how abyssal plains form, discover the delicate rain of marine snow that feeds life in these depths, and meet the extraordinary creatures that call this desolate world home. As we descend, we'll also explore how these plains, invisible to most of us, are vital to the planet's carbon cycle, climate regulation, and even plate tectonics. They hold untapped mysteries, from unknown species to rare minerals, and present both opportunities and ethical dilemmas as humanity eyes them for future exploration. But the abyssal plains are more than just a scientific curiosity. They are a reminder of how much remains undiscovered on our own planet. So, join me as we dive deep to understand not just the geology, biology, and oceanography of this mysterious world, but to connect with the awe it inspires in us all. Abyssal plains are one of the most fascinating and mysterious regions of the ocean, lying deep beneath the surface. These vast, flat expanses are located at depths of around 3,000 to 6,000 meters, 10,000 to 20,000 feet, below sea level and cover nearly half of the ocean floor, making them some of the most extensive environments on Earth. Despite their remoteness and seemingly barren landscape, abyssal plains play a crucial role in the ocean's ecology and our planet's geological history. They're primarily formed through the accumulation of fine particles of sediment that rain down from the water above, a process known as marine snow. This sediment covers the oceanic crust, creating a relatively smooth surface. However, the flatness of these plains is occasionally interrupted by seamounts, ridges, or the remnants of underwater volcanoes. Due to the extreme depth and the absence of sunlight, abyssal plains exist in a perpetually dark, cold environment with temperatures hovering near freezing. The high pressure is immense, reaching levels that would crush most life forms found on the surface. Yet, despite these harsh conditions, the abyssal plains are not lifeless. Unique species of animals have adapted to survive here, including strange fish, bioluminescent creatures, sea cucumbers, and worms. Many of these species rely on the detritus from upper ocean layers for food, though some have adapted to chemosynthetic life around hydrothermal vents. From a geological perspective, abyssal plains are relatively stable. They are part of the oceanic crust, formed from cooling magma at mid-ocean ridges and slowly moving away from these ridges due to plate tectonics. Over millions of years, this movement shapes the seafloor and contributes to the dynamic process of continental drift. The abyssal plains are a critical, though often overlooked, part of Earth's carbon cycle. Organic matter that sinks to these depths becomes buried under layers of sediment, trapping carbon and helping to regulate the planet's climate over geological timescales. Scientific exploration of these plains is still in its infancy, largely due to the difficulty of reaching such depths. However, recent advances in deep-sea submersibles and remote-operated vehicles, ROVs, have allowed researchers to uncover more about these vast undersea landscapes, leading to the discovery of new species and offering insights into the processes that shape our planet. In a sense, the abyssal plains are one of the last great frontiers on Earth, a reminder of how much remains to be discovered about our world's deep ocean. While they may appear desolate and empty, they are, in fact, a realm full of life, geological activity, and environmental importance. Abyssal plains are like hidden chapters of the ocean, tucked away at immense depths where light never reaches. These vast, flat stretches of the seafloor exist miles below the surface, typically between 3,000 to 6,000 meters down, in some of the most remote and inaccessible parts of the Earth. They are found in every ocean on the planet, though the largest are in the Atlantic and Indian Oceans, forming some of the most extensive landscapes on Earth that most people will never see, let alone think about. But just because they're out of sight doesn't mean they're any less remarkable. The formation of these plains is the result of a slow, ancient process. They begin as the ocean floor itself, new crust formed by cooling magma at mid-ocean ridges. Over time, this crust slowly moves outward, spreading away from the ridges and sinking under the weight of the ocean. Meanwhile, fine particles, often microscopic remnants of dead marine organisms, drift down from the water column, blanketing the ocean floor in a layer of sediment. Over millennia, this sediment piles up, smoothing out the rough volcanic terrain and creating the flat, featureless plains we now call the abyssal plains. It's almost paradoxical how something so seemingly barren can be shaped by such a rich and complex set of processes, but that's the nature of the deep ocean, still, but far from static. As desolate as these plains appear, they're not lifeless. In fact, they're part of one of the most unique ecosystems on Earth. Without sunlight, life here has had to evolve in ways that would seem unthinkable on land. Creatures like sea cucumbers, brittle stars, and bioluminescent fish make up much of the abyssal fauna, scavenging on marine snow, the tiny organic particles that drift down from above. It's a minimalist kind of existence, but one that has persisted for eons. Despite the crushing pressure and frigid temperatures, life finds a way to carve out a niche in this alien-like world. The geography of abyssal plains is deceiving. They seem like nothing but endless, empty expanses, and yet, if you could explore them closely, you'd find small ridges, extinct volcanoes, and seamounts dotting the landscape. Each one a reminder that this is a place still shaped by geological forces. Earthquakes, slow shifts in tectonic plates, and even volcanic activity leave their mark on these deep plains, though often in ways that we can only observe through deep-sea exploration equipment. Abyssal plains sit at the crossroads of Earth's slow but constant changes, quietly recording the movements of the planet beneath the oceans. Even though they remain largely unexplored, abyssal plains are incredibly important for our understanding of Earth's past and its future. As part of the ocean's carbon cycle, they play a role in regulating the planet's climate, trapping organic matter that sinks down from the surface. Without them, carbon would accumulate in the atmosphere, potentially altering the balance of global temperatures over time. But these plains do more than just passively collect debris. They are part of the larger story of our planet's geological evolution. As tectonic plates move, these plains slowly shift and change, a reminder that nothing on Earth, not even the most remote and untouched places, remains static. To imagine the abyssal plains is to imagine a world at the edge of our understanding, vast, cold, and seemingly empty, yet filled with mysteries and life that have existed there for millions of years. It's one of the last places on Earth where humans have barely scratched the surface, but perhaps that's fitting. In a world where nearly everything is known and mapped, the abyssal plains remain a quiet, distant frontier. The fact that we still know so little about them adds a layer of allure. Maybe that's why the abyssal plains hold such fascination for scientists. They are a reminder that even in the most seemingly barren places, there is a story being written, slowly, imperceptibly, far beneath the waves. The creation of abyssal plains is one of those quiet, slow-moving processes that happen far out of sight, and yet it's fundamental to how the Earth's surface evolves. Imagine the Earth as a living entity, always changing, reshaping itself, but doing so on a timescale so vast that we can't truly grasp it. Abyssal plains are a part of this process, forming at the boundaries where the Earth's internal forces meet the relentless pressure of the ocean. It all begins deep beneath the ocean at mid-ocean ridges, where molten rock, magma, rises up from the Earth's mantle. As this magma cools, it hardens into new oceanic crust, slowly pushing older crust away from the ridges. It's a bit like a conveyor belt, with new material being created and slowly carried outwards, making room for more. This slow but constant movement is part of what we call seafloor spreading, and it sets the stage for the formation of abyssal plains. But this freshly formed oceanic crust isn't the smooth, flat surface we associate with abyssal plains. At first, it's rough and rugged, dotted with volcanic features and cracks. Over time, though, as the crust moves away from the mid-ocean ridges, something remarkable happens. Tiny particles, most of them the remains of marine life that once lived in the upper layers of the ocean, begin to rain down onto the seafloor. This slow drizzle of organic material is what scientists call marine snow. It falls constantly, settling on the rough oceanic crust and filling in the gaps, creating a more level surface. Over thousands and millions of years, this sediment builds up, smoothing out the landscape until, eventually, the rugged terrain becomes a flat, expansive plain. This process is deceptively simple, yet when you step back and consider how long it takes, how this endless accumulation of tiny particles can transform the very face of the seafloor, it's almost poetic. What started as a chaotic, volcanic landscape gradually becomes one of the smoothest and flattest places on Earth, hidden beneath miles of water. The layers of sediment can be incredibly thick, sometimes reaching hundreds of meters, and they hold within them the history of the ocean above. Each layer tells a story about what was happening in the ocean at the time, what kinds of organisms were living there, and how the environment was changing. In this way, the abyssal plains are like a time capsule, quietly preserving the past. But this isn't just a passive process. The forces that create abyssal plains are linked to some of the most powerful geological phenomena on the planet. As tectonic plates shift and move, they can create earthquakes, volcanic eruptions, and even tsunamis, all of which can impact the seafloor. The movement of the Earth's plates is constantly reshaping the ocean floor, even in places as seemingly calm as the abyssal plains. Sometimes, new volcanic features, like seamounts, can rise from the seafloor, breaking through the layers of sediment. Other times, the slow movement of the plates can cause parts of the oceanic crust to buckle or fracture, creating subtle changes in the landscape. The formation of abyssal plains is also tied to the larger cycle of plate tectonics. As the oceanic crust ages and moves further away from the mid-ocean ridges, it cools and sinks deeper into the mantle. Eventually, in some places, this crust is pulled down into subduction zones, where it is recycled back into the Earth's interior. But before that happens, the crust may spend millions of years as part of an abyssal plain, slowly accumulating sediment and contributing to the complex, ever-changing landscape of the deep ocean. What makes the abyssal plains so fascinating is the way they represent both the stability and the constant motion of the Earth. On the one hand, they are some of the most stable and unchanging environments on the planet, vast, flat expanses where little seems to happen on a human timescale. On the other hand, they are deeply connected to the forces of plate tectonics, which are constantly at work, shaping the Earth's surface in ways we can't see or feel in our daily lives. The plains are a reminder of the immense forces that lie beneath our feet, forces that are responsible for creating not just the land we live on but the vast, hidden landscapes of the deep ocean. In the end, the formation of abyssal plains is a quiet process, but it's one that speaks to the incredible power of time and the Earth's inner workings. They may not be as dramatic as mountains or as dynamic as rivers, but they are every bit as essential to the planet's story, shaped by forces that are as ancient as the Earth itself. Marine snow is one of those strange, beautiful phenomena that occur in the deep ocean, far removed from anything we typically think about when we consider life on Earth. Picture it. In the vast darkness, miles below the ocean's surface, where sunlight doesn't reach and life seems almost impossible, tiny flecks of organic matter drift slowly downward. This steady fall of debris, made up of dead plants, animals, fecal matter, and other organic particles, is what scientists call marine snow. It's as though the ocean is constantly shedding its upper layers, letting the remains of life from the surface settle into the depths, feeding the mysterious world below. What makes marine snow fascinating is that it's not just waste or random particles. It's a lifeline for the creatures living in the abyssal plains. In an environment where resources are scarce and sunlight is non-existent, marine snow becomes a crucial source of sustenance. Tiny organisms, plankton, and algae from the upper layers of the ocean, where sunlight still penetrates, die and decompose, forming these organic particles. As they fall, they are slowly consumed by a cascade of life forms, from microorganisms near the surface to the bizarre creatures that live in the depths. The deeper the particles travel, the fewer of them remain intact. But even in the abyssal plains, some of this organic matter makes it all the way down, creating the foundation for a fragile ecosystem. Down on the abyssal plains, the creatures that survive in these harsh conditions have adapted to live off what little reaches them. There's a kind of quiet efficiency to it. Sea cucumbers, brittle stars, and other scavengers patrol the seafloor, feasting on the tiny bits of marine snow that accumulate there. For these creatures, the snow is both a meal and a link to the surface, a connection to a world they'll never see. They live off the leftovers of the ocean's surface ecosystem, using every bit of energy they can extract from the organic material that drifts down. Without marine snow, these deep-sea organisms would starve, as there's almost no other way for them to get the nutrients they need to survive. What's even more remarkable is that marine snow contributes not only to the biological health of the abyssal plains, but also to the overall stability of the planet's carbon cycle. As these tiny particles sink, they carry with them carbon that had been captured by surface organisms, essentially sequestering it on the ocean floor. This process plays a role in regulating the amount of carbon dioxide in the atmosphere, impacting everything from climate patterns to the health of ocean ecosystems. It's a silent process, one that happens far out of sight, but it's vital for the balance of life on Earth. The slow, steady fall of marine snow can continue for weeks, even months, and the deeper it goes, the more the particles are transformed by the creatures that feed on them. By the time it reaches the abyssal plains, the organic matter is sparse and scattered, but it's enough to sustain life in this cold, dark world. In some ways, the creatures down here live in a state of perpetual waiting for the next bit of snow to drift down, providing the nutrients they need to keep going in an environment that offers them little else. It's a precarious existence, but one that's perfectly suited to the slow, patient rhythms of the deep ocean. There's something humbling about marine snow when you think about it. On the one hand, it's just debris, dead organisms, waste, broken bits of life from the surface. But on the other hand, it's this delicate, essential thread that connects the surface world to the deep. It's a reminder that even in the most unlikely places, life finds a way to persist, using every scrap of available energy to keep going. And it's not just the creatures of the abyssal plains that rely on it. In a way, the whole planet benefits from the quiet, continuous rain of marine snow. It's one of those natural processes that we rarely think about, but that shapes the world in profound, far-reaching ways. The species that inhabit the abyssal plains are the ultimate survivors, creatures that have evolved to thrive in conditions that seem almost hostile to life itself. Down there, at such crushing depths and in the pitch-black darkness, the inhabitants of this world have developed in ways that feel entirely alien. It's hard to imagine how anything could live in such an extreme environment, but these species have found their niche, carving out a life in the cold, high-pressure world of the abyss. One of the most common inhabitants of the abyssal plains is the sea cucumber. At first glance, it's an odd creature, tube-like, soft-bodied, and sluggish. But what it lacks in charm, it makes up for in sheer adaptability. Sea cucumbers play a critical role in the abyssal ecosystem, sifting through the sediment that covers the ocean floor. They feed on organic particles, including marine snow, recycling nutrients and helping maintain the balance of this deep-sea world. They are, in essence, the cleaners of the abyss, quietly breaking down the detritus that drifts down from the surface. Their simple, slow movements are perfectly suited to the lethargic pace of life in this isolated part of the ocean. Then there are the brittle stars, cousins of the more familiar starfish, though these creatures seem almost fragile by comparison. Their thin, flexible arms stretch out from a small central body, allowing them to crawl across the ocean floor with a surprising grace. Like sea cucumbers, brittle stars are scavengers, feeding on whatever organic material they can find, whether it's marine snow or the remains of other deep-sea creatures. They're surprisingly active for abyssal species, and their movements, though slow and methodical, make them a more dynamic presence in the landscape of the plains. Fish that inhabit the abyssal plains are equally strange, adapted to the cold, dark environment in ways that make them seem otherworldly. The tripod fish, for example, is a peculiar sight. It stands on the seafloor using long, extended fins that act like stilts, allowing it to remain motionless as it waits for prey to drift by. In an environment where food is scarce, this patient, energy-conserving approach is essential for survival. The tripod fish doesn't waste energy swimming through the water. Instead, it lets the ocean's currents do the work, bringing small crustaceans and other prey directly to it. And then there are the deep-sea amphipods, small, shrimp-like creatures that might be easy to overlook if they didn't play such a vital role in the ecosystem. Amphipods are scavengers, much like the brittle stars and sea cucumbers, but they are also prey for many of the other species in the abyss. Despite their small size, they are an important part of the food chain, serving as a critical link between the microscopic world of marine snow and the larger predators of the abyss. These larger predators, though not as abundant as the scavengers, are some of the more intriguing inhabitants of the abyssal plains. Deep-sea fish like the anglerfish and gulper eel are masters of survival in the darkness. The anglerfish, with its infamous bioluminescent lure, uses a glowing appendage to attract prey, which it can then snap up with its sharp, menacing teeth. It's an eerie but effective adaptation in a world where light is scarce and hunting is a challenge. The gulper eel, on the other hand, has an oversized mouth that allows it to swallow prey much larger than itself, an advantage in a place where food is hard to come by and meals can be few and far between. Despite the vast emptiness of the abyssal plains, life here has found ways to flourish, not through abundance, but through efficiency. The creatures of this realm have evolved to make the most of what little they have, conserving energy, scavenging whatever food is available, and patiently waiting for the next opportunity to eat. The abyss is a world defined by scarcity, and the species that live here are experts in survival. Their bodies and behaviors fine-tuned to handle the extremes of pressure, cold, and darkness. What's remarkable about these species is that, despite living in such a remote and seemingly desolate place, they are part of a larger, interconnected web of life that stretches all the way to the ocean's surface. They feed on the remains of life from above, and in turn, they sustain the predators that venture into the deep. It's a delicate, finely balanced system that depends on the slow, steady rain of organic material from the upper ocean, and it highlights just how interconnected the entire planet's ecosystems truly are. Even in the depths of the abyss, life continues, quietly and patiently, adapted to a world that most of us can hardly imagine. The creatures that live in the abyssal plains face conditions so extreme that it's difficult for us to truly grasp how they survive. It's like imagining what life would be like on another planet. Intense pressures that could easily crush the body of any land animal, freezing temperatures that hover just above freezing, and complete, absolute darkness. And yet, life not only exists in these depths, but has evolved in ways that are almost unimaginable to deal with these harsh conditions. Pressure, for one, is relentless at these depths. The deeper you go in the ocean, the more weight is stacked above you, and in the abyssal plains, that weight is immense. The pressure is equivalent to having 1,000 elephants standing on top of you, which sounds impossible to withstand. But the creatures down here don't just endure it, they've adapted to it as part of their reality. Their bodies are built to handle it. Many of these animals have no air-filled cavities, like lungs or swim bladders, which would be crushed under such pressure. Instead, their bodies are soft, almost gelatinous in nature. Fish like the blobfish, which look almost cartoonish when brought to the surface, are perfectly adapted to life under crushing pressure. Up on land or at shallower depths, their bodies lose their shape and structure, but in the deep, they're perfectly at home, their softness allowing them to survive where more rigid organisms would collapse. Temperature is another obstacle, with the abyssal plains being one of the coldest environments on Earth. Down there, the water is just above freezing, but these creatures have evolved to survive in the cold. Unlike animals that live in warmer waters or on land, the metabolism of abyssal species is much slower. Everything moves at a different pace in the deep. Their bodies don't burn energy quickly, allowing them to survive on very little food, which is important when resources are so scarce. Some deep-sea animals produce special proteins that act almost like antifreeze, preventing their bodily fluids from freezing solid in the near-zero temperatures. It's a kind of biochemical miracle that allows them to live in conditions where most life would be immobilized by the cold. Darkness, too, is a constant companion in the abyss. With no sunlight penetrating to these depths, the world of the abyssal plains is completely devoid of natural light. Yet, these creatures have adapted not by relying on sight, but by evolving other senses. Some, like the anglerfish, have developed bioluminescence, a biological ability to produce light. In the blackness of the abyss, their glowing lures or patches of light act as beacons, either to attract prey or communicate with potential mates. For others, like deep-sea crabs, vision is replaced by heightened sensitivity to changes in water pressure or chemical signals. They can sense the movement of water and the faintest hint of food through highly sensitive receptors. It's as if their world is one of feeling and intuition rather than sight. The animals that live in this environment also seem to understand the importance of conserving energy. In a place where food is scarce, it's not about constant activity but waiting and making every move count. Many of these creatures are opportunistic, ready to devour whatever falls their way, whether it's a bit of marine snow or the occasional dead whale that sinks to the bottom. When a large meal presents itself, these creatures gorge, knowing that it might be weeks, months, or even longer before they eat again. They have evolved to survive long periods without food, slowing their metabolisms even further during lean times. For some species, the abyssal plains aren't just a place to live, they're a sanctuary. Here, far removed from the sunlit world above, they avoid many of the predators that roam the upper waters. Without the constant threat of predation, they can afford to move slowly, conserve energy, and live longer lives than many of their shallow water counterparts. In a way, the abyssal plains provide a kind of stability where time stretches out and life moves at a different rhythm. It's in this alien world, so far removed from anything we're used to, that life finds a way. Creatures that would seem fragile or bizarre to us are masters of survival, shaped by their environment in ways that seem almost impossible. But for them, this is home, and their bodies, minds, and behaviors are perfectly tuned to the abyss. It's a stark reminder of how adaptable life can be, no matter how extreme the conditions. Abyssal plains, though far from our everyday thoughts, play a vital role in the Earth's carbon cycle, quietly working beneath miles of ocean to help regulate the planet's climate. At first glance, the abyssal plains might seem like an empty, desolate expanse, but their importance is deeply intertwined with the way carbon moves through the oceans and the atmosphere, a process that affects everything from the air we breathe to the stability of global temperatures. At the heart of this connection is the concept of carbon sequestration, where carbon from the atmosphere is stored in the deep ocean, and the abyssal plains are one of the final resting places for much of this carbon. It all starts at the surface, where tiny organisms, particularly phytoplankton, absorb carbon dioxide during photosynthesis. These microscopic plants form the base of the ocean's food web, pulling carbon out of the air and into the biological systems of the ocean. As they die, or as animals feed on them and produce waste, much of this carbon becomes trapped in particles that begin their slow descent toward the ocean floor. This is where the abyssal plains come into the picture. These particles, often referred to as marine snow, drift downward, carrying with them the carbon that had been captured by the phytoplankton. As they fall, they pass through various layers of the ocean, slowly being decomposed or consumed by creatures along the way. But not all of it is broken down. Some of these carbon-rich particles reach the bottom, where they settle on the abyssal plains, effectively locking away that carbon for centuries, even millennia. It's a slow, deliberate process, but over time, the abyssal plains act as a massive carbon sink, storing immense amounts of carbon in their sediments. The creatures that live on the abyssal plains, like sea cucumbers and brittle stars, play a role in this as well. As they scavenge and consume organic material that makes its way to the seafloor, they process it, breaking it down further and incorporating it into their bodies or the sediment. Their activity helps bury some of the carbon even deeper into the ocean floor, where it becomes part of the geological carbon cycle, potentially staying there for millions of years. In this way, the abyssal plains aren't just a passive landscape, but an active part of the carbon storage process. Over time, the carbon that gets trapped in the sediments of the abyssal plains can even be incorporated into the Earth's crust. Through tectonic activity and the movement of oceanic plates, some of this carbon will eventually be subducted into the Earth's mantle, where it may remain for an incredibly long period. In rare cases, the carbon can be released back into the atmosphere through volcanic activity, but for the most part, the abyssal plains serve as a long-term repository for this element, preventing it from re-entering the carbon cycle. The significance of this process becomes clear when you think about the bigger picture. Carbon dioxide is a greenhouse gas, and its levels in the atmosphere directly influence global temperatures and climate patterns. By sequestering carbon in the deep ocean, abyssal plains help to moderate the amount of CO2 that remains in the atmosphere. This natural mechanism has been a crucial factor in maintaining the Earth's climate over long periods. Without this deep-sea carbon storage, more carbon would remain in the atmosphere, likely accelerating the warming of the planet. It's almost paradoxical that such a seemingly barren, quiet place could have such an outsized impact on the global carbon cycle. The abyssal plains may be remote and largely unexplored, but they are a critical part of the Earth's life support systems. In the grand scheme of things, they serve as a final checkpoint in the carbon journey, where what was once part of the living, breathing surface world is laid to rest, helping to stabilize the environment we depend on. Their role in the carbon cycle may be slow and understated, but it's one of the key reasons our climate has remained relatively stable for so long. Without the abyssal plains and the vast store of carbon they hold, the balance of life on Earth would look very different. The abyssal plains, though tucked away in the ocean's depths and far from our daily lives, play an integral role in global climate regulation. It's surprising to think that such a remote, seemingly lifeless part of the planet can have a hand in shaping something as vast as Earth's climate, but it does, working silently and persistently over millennia. One of the key ways it impacts climate is through its role in the carbon cycle, acting as a massive, long-term carbon sink. When you imagine the deep ocean floor, you're picturing one of the largest storage spaces for carbon on Earth, and this has a profound effect on how heat is trapped or released in the atmosphere. As carbon dioxide builds up in the atmosphere, it's a bit like adding more insulation to a house. The more CO2 there is, the more heat gets trapped, and the warmer things become. What the abyssal plains help do is store much of that excess carbon away, where it can't contribute to this heating process. The journey begins at the surface, where carbon from the air dissolves into the ocean and is captured by tiny organisms in the form of organic matter. Over time, as these organisms die or release waste, the carbon they hold begins a slow, sinking journey to the ocean floor, settling on the abyssal plains. Once it reaches these depths, it's effectively locked away, kept out of the atmosphere where it could exacerbate global warming. In essence, the abyssal plains are part of the Earth's natural mechanism for cooling itself. By sequestering carbon in the deep-sea sediments, they help to prevent an overload of greenhouse gases in the atmosphere, ensuring that temperatures don't spiral out of control. It's a slow but vital process. Without this deep-sea storage system, the balance of carbon would be disrupted, and more of it would remain in the air, accelerating climate change. In fact, these vast stretches of the ocean floor are among the most efficient carbon sinks we have. They might not work fast by human standards, but over thousands and even millions of years, they have a stabilizing effect that helps regulate the planet's climate on a geological timescale. But it's not just about carbon. The abyssal plains also influence the distribution of heat within the ocean itself. Ocean currents, driven by differences in water temperature and salinity, play a critical role in regulating climate. As warm water moves from the equator toward the poles and cooler water sinks and flows back toward the tropics, the ocean acts like a giant conveyor belt, redistributing heat around the planet. The abyssal plains are part of this system, with deep ocean currents flowing across them, carrying cold, dense water that helps cool the lower layers of the ocean and, by extension, the planet. These deep waters interact with the abyssal plains in ways we are only beginning to fully understand, but their presence helps to stabilize the ocean's temperature, preventing dramatic shifts that could impact global climate systems. There's something almost poetic about the way the abyssal plains quietly manage the Earth's climate, hidden from view, yet always at work. They're not dramatic in the way that glaciers melting or wildfires burning are, but their contribution is every bit as important. If the carbon stored in their depths were to be released, it could have catastrophic effects on global temperatures. Similarly, if the delicate balance of ocean currents flowing over the plains were disrupted, the entire system of heat distribution that regulates climates around the world could be thrown into chaos. In this way, the abyssal plains act like the deep foundation of a house, providing support and stability to the systems we rely on. They absorb, store, and balance, ensuring that the forces of nature remain in check. It's easy to overlook them because they're so far removed from human life, but their impact is immense. They are, in many ways, the Earth's hidden regulators, quietly maintaining the balance that allows life to thrive on the surface, ensuring that the planet's climate remains within the bounds of habitability. And while we may not see their effects day to day, their influence is woven into the very fabric of the planet's climate system, making them an essential part of the larger story of Earth's resilience. The abyssal plains, vast and seemingly endless, stretch beneath the ocean's surface like an underwater desert, their quiet monotony interrupted only by the occasional deep-sea creature or the presence of strange geological formations. At first glance, they appear as the most desolate part of the ocean, their flatness almost hypnotic. Yet, these plains, lying about 3,000 to 6,000 meters below the surface, are far from lifeless. They teem with microscopic life, strange bottom-dwelling creatures, and they are rich with fine sediments that have accumulated over millions of years. Despite their stillness, the abyssal plains play a vital role in Earth's ecological balance, acting as a reservoir for organic material and a critical part of the carbon cycle. These regions feel remote but are surprisingly connected to life on the surface through currents and the gradual rain of marine snow, decomposing organic matter that drifts down from above, feeding the organisms below. But venture deeper still, beyond the abyssal plains, and the ocean begins to change into something even more mysterious. The Hadle zone, starting at depths of around 6,000 meters and plunging into the Earth's deepest trenches, is a place where light has never touched and pressure reaches unimaginable extremes. The creatures here, shaped by this harsh reality, are the definition of resilience, enduring conditions that would crush nearly anything else. Unlike the relative openness of the abyssal plains, the Hadle zone is shaped by steep, narrow trenches and jagged canyons, remnants of tectonic activity that pulled the Earth's crust apart. It is a place of extremes, where life must adapt to an ever-present threat of collapse, where ecosystems are far more isolated than on the plains above. What sets these two environments apart is not just the depth or pressure, but the way they feel to those who study them. The abyssal plains are barren yet tranquil, stretching endlessly as if the world above never existed. They are flat and uniform, providing space for creatures that live slow, methodical lives, surviving off the thin trickle of nutrients. This environment, though strange, feels closer to a steady rhythm, quiet but somewhat predictable. Life on the abyssal plains moves at its own pace, with creatures like sea cucumbers and brittle stars quietly crawling across the sediment, and deep-sea corals growing in solitude, thriving in the darkness. In the Hadle zone, however, there is no such predictability. The crushing pressures and geological instability make it a place of stark contrasts. Here, entire communities may cling to hydrothermal vents or survive near cold seeps, where chemical-rich fluids ooze from the seafloor. These are ecosystems completely divorced from sunlight, relying instead on chemosynthesis for energy, a strange and almost alien process. The landscape itself is far from smooth, as trenches and escarpments create an environment full of dramatic slopes and towering walls. The organisms of the Hadle zone are even more specialized, built to endure the weight of the ocean above them. There's an eeriness to this region, where creatures like amphipods scavenge through the pitch black, and giant tube worms seem almost otherworldly, their pale bodies standing out in the shadowy depths. While the abyssal plains could be seen as an eerie reflection of the barren stretches of a desert, the Hadle trenches resemble something more akin to the bottomless chasms of our imagination, dark, unpredictable, and seemingly infinite. The differences between these two environments are not only scientific but also psychological. The abyssal plains, in all their monotony, represent a kind of boundary where human understanding can still stretch, albeit tenuously. We can grasp the idea of a flat, sediment-filled expanse, though we might struggle with the endless quiet of such a place. The Hadle zone, however, feels like the ocean's own secret, a place where the rules of life and survival shift dramatically, and where humans have barely scratched the surface of understanding. The depths of the Hadle zone confront us with the limits of our knowledge, pushing us to imagine life that thrives under unimaginable stress, yet remains unseen by all but the most advanced exploration efforts. It's the interplay of life, geography, and sheer mystery that separates the abyssal plains from the Hadle trenches. Both are worlds within the same ocean, yet their differences hint at the variety of challenges life must overcome in the deep. The plains, though distant, are still reachable, still somewhat familiar in their eerie emptiness. The Hadle zone, however, feels like another world entirely, where the ocean's true depths hide in shadows and pressures that test the very fabric of survival. Beneath the crushing weight of the ocean, far from any sunlight, there are rare places where the sea floor suddenly becomes a landscape of unexpected vitality. Hydrothermal vents and cold seeps, though different in origin, both provide an oasis of life in an otherwise barren world. These environments are not scattered randomly, but when they do occur, they transform the abyssal plains around them, turning what might seem like an underwater wasteland into a thriving, if alien, community. The contrast is stark. Where the abyssal plains are mostly quiet and slow-moving, hydrothermal vents and cold seeps create zones of activity, where life has learned to flourish in ways almost unimaginable elsewhere. Hydrothermal vents, in particular, are the result of volcanic activity deep beneath the ocean floor. When tectonic plates shift, they allow seawater to seep down into cracks in the Earth's crust, where it's heated by molten rock before surging back out, laden with minerals. What happens next is extraordinary. As the superheated, mineral-rich water hits the frigid depths, it solidifies into towering chimneys, known as black smokers, spewing plumes of dark, sulfurous clouds. Around these vents, life gathers, feeding off the chemical energy that pours out in the form of hydrogen sulfide. This process, called chemosynthesis, is like a mirror of the photosynthesis happening far above. But here, instead of sunlight, it's chemicals that fuel the growth of strange organisms. The effect on the surrounding ecosystem is dramatic. In an environment where energy is typically scarce, the vents become hotbeds of activity. Entire communities of organisms cluster around the vents: giant tube worms, crabs, clams, and unique species of bacteria, all living off the chemical-rich water. These creatures are bizarrely adapted to their environment. Tube worms, for example, have no mouths or digestive systems. Instead, they rely on symbiotic bacteria within their bodies to process the hydrogen sulfide they absorb. For a brief moment, the abyssal plain, which is otherwise a quiet expanse of sediment, becomes a buzzing network of life. The presence of the vents draws in predators and scavengers from further away, and suddenly, This remote corner of the ocean becomes a vibrant hub of interaction and survival. Cold seeps, though less dramatic in appearance, create similar ecosystems in the abyssal plains. Unlike the explosive heat of hydrothermal vents, cold seeps are slow, steady leaks of methane or hydrogen sulfide from the seabed, typically occurring at the edges of continental margins. These seeps don't have the violent energy of vents, but they quietly release nutrients into the surrounding water, feeding life in much the same way. The organisms that gather here, too, rely on chemosynthesis, though the pace of life around a cold seep is more subdued compared to the rapid frenzy around a hydrothermal vent. The seeps provide a continuous flow of energy, attracting tube worms, mussels, and specially adapted fish that can survive on the chemicals seeping from the ocean floor. The ecosystems around these seeps are remarkable for their resilience, not just because they exist in extreme environments, but because they bring a kind of balance to the abyssal plains. The plains themselves are often described as deserts, with nutrients arriving slowly and life moving at an almost imperceptible pace. But the cold seeps act like small pockets of sustenance, drawing creatures from miles away to partake in the chemicals they release. Over time, the sediment around these seeps can even become enriched by the organic material produced by the organisms living there, altering the surrounding environment in subtle but significant ways. What makes both hydrothermal vents and cold seeps so fascinating is their ability to create life where none should exist. These ecosystems influence the abyssal plains by adding an unexpected layer of complexity to an otherwise barren seafloor. They show us that even in the harshest, most desolate parts of the ocean, life finds a way to flourish, not just survive, but to thrive in astonishing abundance. There's something profoundly human about the way life clings to these energy sources, despite the isolation and the extreme conditions. It's a reminder that in the vastness of the deep ocean, life is as much about persistence as it is about adaptation. Hydrothermal vents and cold seeps are rare, but their influence spreads far beyond their immediate surroundings, hinting at the unseen connections that link even the most remote parts of the Earth to the rest of the planet's living systems. Exploring the abyssal plains is a journey into a world that feels more like stepping onto another planet than venturing beneath the oceans we think we know. The sheer remoteness of these vast stretches of the seafloor presents a challenge that is almost incomprehensible to the human mind. There are no landmarks to guide you, no light to illuminate the way, just endless darkness and the crushing weight of the sea above. The abyssal plains are some of the most isolated places on Earth, and reaching them requires overcoming both technological and physical barriers that few other environments demand. The first obstacle is simply getting there. The depths of the abyssal plains, often lying at 3,000 to 6,000 meters below the surface, are far beyond the reach of human divers. The immense pressure at these depths would crush the human body in an instant, making direct exploration impossible without the most advanced technologies. Submersibles and remotely operated vehicles, ROVs, are essential tools, but even these machines must be specially designed to withstand the crushing forces. Every descent is a calculated risk. If a single component fails, the pressure could cause catastrophic damage, and there's no quick rescue from the bottom of the ocean. Each mission is a reminder of just how fragile our technology can be in the face of nature's most extreme environments. The distance from the surface also means that communication is painfully slow. Sending instructions or receiving data from an ROV takes time, and the further it goes, the more delayed the responses become. This makes real-time decision-making a difficult task. Scientists often have to rely on pre-programmed missions or carefully planned routes, hoping that the vehicles will capture what they need before they can even begin to interpret the data. It's a delicate dance of patience and precision, where every error or oversight can cost hours, if not days, of valuable research time. Then, there's the issue of the environment itself. The abyssal plains, while relatively flat, are covered in a thick layer of fine sediment that has been slowly building up over millions of years. The slightest disturbance can send clouds of sediment billowing into the water, obscuring vision and making it nearly impossible for cameras or sensors to gather clear data. This means that every movement must be slow and deliberate, adding yet another layer of difficulty to an already painstaking process. It's like trying to walk through a room full of dust without stirring up a single particle. One wrong move, and you're left in a haze. Even when equipment functions perfectly and the environment is cooperative, the vastness of the abyssal plains poses a challenge that's hard to grasp. These are enormous, featureless expanses, stretching for thousands of kilometers in some cases. Locating specific areas of interest, such as hydrothermal vents, geological formations, or unique ecosystems can feel like searching for a needle in an ocean-sized haystack. The lack of any prominent landmarks makes navigation a slow, methodical process, requiring the use of sonar mapping, detailed planning, and a great deal of luck. What little we know of these plains has been pieced together from brief glimpses and scattered data points, making each new discovery feel both monumental and frustratingly incomplete. But beyond the technical challenges lies an emotional one. There's a profound sense of isolation that comes with exploring the abyssal plains, even from the relative safety of a research vessel on the surface. The knowledge that you are peering into a part of the Earth that has remained untouched for millennia can be both exhilarating and overwhelming. This is a place where time moves differently, where the rhythms of life and death are measured in geologic scales rather than human ones. Studying the abyssal plains requires not only scientific expertise, but a kind of mental endurance. It's easy to get lost in the sheer emptiness of it all, to feel like you are peering into the void with little hope of truly understanding what you see. The cost, both financial and in terms of human effort, is enormous as well. Launching a deep-sea expedition requires massive investments in specialized equipment, months of planning, and the coordination of teams across various disciplines. The abyssal plains are not a place you can explore on a whim. Each trip is the culmination of years of preparation, and the stakes are high. Every hour spent in the depths is a race against time, as each mission comes with strict limits on how long equipment can remain operational before it must return to the surface for maintenance. All of this, the technological hurdles, the environmental difficulties, the psychological toll, creates an experience that is both daunting and awe-inspiring. To explore the abyssal plains is to come face to face with the extremes of our planet, where the familiar rules of life and movement seem to bend. It's a reminder of how much we still don't know, how small our understanding is in the face of the deep ocean's mysteries. Every new discovery brings us closer to unraveling the secrets of these remote places, but it also serves as a humbling reminder that some parts of the Earth remain stubbornly beyond our reach, shrouded in darkness and silence. The exploration of the abyssal plains has been made possible by a series of technological leaps that seem almost as incredible as the depths themselves. It's hard to imagine, but just a few decades ago, these remote parts of the ocean were completely out of reach. The crushing pressures, the freezing temperatures, the total absence of light. All of it created a barrier that kept human eyes from ever witnessing what lay beneath. But with each new innovation, those barriers started to crumble, and the abyssal plains became a little less distant, though they still remain among the least explored places on Earth. Submersibles, for instance, changed everything. The early models were rudimentary, capable of only brief descents and limited maneuverability, but they cracked open the door to the deep. The challenge wasn't just getting to the abyssal plains, it was staying there long enough to observe and collect data. Modern submersibles, equipped with thick titanium hulls and advanced life support systems, can now dive deeper and stay submerged longer than ever before. These machines carry the weight of human curiosity into a world where human presence alone would be impossible. The submersibles themselves feel almost like extensions of the people who control them, turning what was once an unreachable frontier into a place we can touch, even if it's through a screen. Remotely operated vehicles, or ROVs, push that boundary even further. These robotic explorers don't just visit the abyssal plains, they linger there. They're tethered to surface ships by miles of cable, sending back real-time images, data, and samples. The advantage of ROVs is their ability to go where submersibles can't, maneuvering through tight spaces or staying in one place for extended periods. They are equipped with robotic arms that delicately pick up samples from the seafloor, capturing tiny fragments of this distant world and bringing them back to the surface. Watching one of these machines navigate the dark, alien landscape of the abyssal plains is like watching a hand reach out from the surface, bridging the gap between worlds. But it's not just about getting down there. It's about seeing and understanding. High-resolution cameras and lights, built specifically to withstand the immense pressures of the deep, have given us our first clear views of these remote regions. The early images from the abyssal plains were grainy and indistinct, but today's cameras capture every detail with stunning clarity. This shift in visual technology has been more than just a scientific tool. It's been an emotional one. Seeing these places in high definition, witnessing the strange and beautiful life that thrives in the darkness, has made the abyssal plains feel a little less foreign, even though they remain far beyond our reach. Mapping technology has also transformed our understanding of the seafloor. Sonar systems now allow us to map vast areas of the abyssal plains with remarkable precision. Ships send sound waves down into the depths, which then bounce back, creating detailed maps of the topography below. It's like peering into the unknown, one echo at a time. These maps reveal the subtle ridges, valleys, and plains that make up the landscape, guiding explorers to areas of interest. Without these detailed maps, finding anything on the abyssal plains would be like searching for a single grain of sand in an endless desert. The sonar systems have given shape to what was once thought to be an entirely featureless expanse. Perhaps one of the most fascinating developments in recent years has been the use of autonomous underwater vehicles, or AUVs. These are the true pioneers of the deep, machines that are programmed and sent on long missions, completely untethered from the surface. AUVs dive to the abyssal plains, following predetermined routes, collecting data as they go. They operate independently, sometimes for days or weeks at a time, navigating the dark waters with a kind of mechanical intuition. When they return to the surface, they bring with them a wealth of information about the seafloor that no human eyes have ever seen. These robotic explorers represent a new frontier in deep-sea exploration, one that hints at the future of how we will continue to unlock the secrets of the abyssal plains. The development of sensors capable of withstanding the extreme conditions of the abyssal plains has also been crucial. These sensors measure everything from temperature and salinity to chemical composition and pressure. Each piece of data adds to the larger picture of how life survives and ecosystems function in the most extreme environments on Earth. It's not just about what we see, but what we can feel through these instruments. They allow us to experience the deep ocean in ways that go beyond visual observation, providing insights into the physical and chemical conditions that shape life in these remote places. All of these advancements are intertwined with the human spirit of exploration. They are the tools we've created to answer a fundamental question: what lies beneath? But the technology alone isn't enough. It's the people behind it, the engineers, scientists, and explorers who have made this possible. Each new piece of equipment is the result of years of innovation, trial and error, and an unrelenting desire to go further, deeper, to see what has never been seen before. This desire to explore is as much a part of the story as the machines themselves. The abyssal plains, in all their mystery, have called out to us, and with each new advancement, we edge a little closer to answering that call. The challenges are far from over. The ocean's depths still hold more secrets than we've uncovered, and the technology we rely on remains delicate in the face of the planet's most extreme environment. But each new discovery reminds us that we are capable of remarkable things, that even in the darkest, most remote corners of the Earth, there is life and there is beauty waiting for us to find it. The abyssal plains, though vast and seemingly silent, play a crucial role in the constant, invisible movements of the Earth's surface. They are not just empty expanses of ocean floor, but are part of the dynamic system that shapes our planet, one in which the forces of plate tectonics and oceanic crust formation quietly, yet powerfully, govern the rhythms of the Earth. This deep seafloor, lying between mid-ocean ridges and continental margins, is a place where the planet's inner workings reveal themselves in subtle but profound ways. As new oceanic crust forms at mid-ocean ridges, molten rock from beneath the Earth's surface rises, cools, and solidifies, creating fresh seafloor. This process, known as seafloor spreading, is one of the fundamental mechanisms driving plate tectonics. The abyssal plains are shaped by this process, as they are the vast areas where this new crust spreads out over time. The slow, steady movement of tectonic plates pulls the seafloor away from the ridges, and as the new crust moves further from its source, it cools and sinks, becoming part of the abyssal plains. This quiet spreading is what makes these plains some of the flattest, most uniform surfaces on the planet, even though they are constantly being created and reformed in the depths. This process of seafloor spreading is not something we can see or feel from the surface, but its effects are everywhere. The abyssal plains, though they appear static, are part of an immense conveyor belt of crustal material moving across the ocean basins. As the plates shift, they carry continents with them, subtly but inevitably altering the geography of the Earth over millions of years. The significance of the abyssal plains and plate tectonics is that they are the record keepers of this slow-motion drift. Layers of sediment that accumulate on these plains capture the history of Earth's movements, preserving evidence of past climates, ocean conditions, and even the magnetic reversals of the planet's poles, which are frozen into the rocks as they form. But the abyssal plains are not just passive bystanders in the grand tectonic drama. They play an active role in the recycling of Earth's crust. As oceanic plates move away from the ridges, they eventually encounter the edges of continental plates in a process known as subduction. When this happens, the older, denser oceanic crust is forced downward into the mantle, where it melts and is recycled back into the Earth's interior. The abyssal plains, over time, are pulled toward these subduction zones, where they disappear beneath the continents, only to be reborn at the mid-ocean ridges once again. This cycle of creation and destruction is one of the great balancing acts of the planet, and the abyssal plains are caught in the middle of it. The connection between the abyssal plains and oceanic crust formation is one of constant renewal. While the continents have remained largely stable over geologic time, the oceanic crust is continually being remade. The abyssal plains are a testament to this ongoing cycle. They show us that the Earth's surface is never truly settled, that even in the deepest parts of the ocean, change is happening, often imperceptibly, but on a scale that dwarfs anything happening on land. In many ways, the abyssal plains are the undercurrent of plate tectonics, the quiet force that ensures the planet's surface remains in motion, reshaping itself as it has for billions of years. This cycle also hints at something deeply human, the notion of transformation, of renewal in the most unexpected places. Just as the ocean floor is constantly being born, moving, and eventually returning to the depths from which it came, we, too, exist in a state of continuous change, often without realizing it. The abyssal plains remind us that even the most stable-seeming things, whether it be the earth beneath our feet or the ideas we hold onto, are subject to forces greater than we can see, forces that slowly reshape everything over time. And yet, for all the movement, there's a strange sense of permanence as well. The abyssal plains, in their vastness, carry with them the weight of geological time. They give us a glimpse into the Earth's ancient processes, operating on timescales so immense that they make human history seem fleeting. The plains themselves, though formed by the relentless movement of tectonic plates, appear to stretch on endlessly, offering a sense of stillness even as they are slowly drawn into the tectonic cycle. This paradox, of constant motion in the face of apparent stillness, gives the abyssal plains a kind of quiet power in the story of our planet. As we explore and study these depths, we come to understand that the abyssal plains are not just features of the deep ocean, but essential parts of the Earth's living, breathing system. They are where the planet's tectonic activity is both recorded and renewed, where the oceanic crust is created, spread, and eventually returned to the Earth. In the depths, beneath miles of ocean, the abyssal plains hold the secrets of the planet's past and future, constantly reminding us of the delicate balance that sustains life on Earth. Beneath the seemingly endless expanse of the abyssal plains, the Earth is alive with activity that most will never see or feel. Underwater volcanic eruptions, which are frequent in the deep sea, and the towering presence of seamounts, slowly rising from the seafloor, are powerful forces that continually shape these vast stretches. While the abyssal plains often appear flat and featureless in our imaginations, they are anything but static. The influence of volcanic activity and seamounts creates subtle and not-so-subtle changes across the landscape, often leaving a lasting mark on the ocean's deepest floors. Underwater volcanoes erupt with a quiet fury in the darkness of the deep, far from human eyes, but with effects that ripple through the abyssal plains. As molten rock from beneath the Earth's crust forces its way through cracks on the ocean floor, it spills out as lava, which then cools rapidly in the freezing water. Over time, this lava hardens into new crust, creating rocky formations and often lifting sections of the seafloor. The abyssal plains, despite their general flatness, are regularly reshaped by this process. These volcanic eruptions are not the dramatic, fiery explosions we associate with surface volcanoes, but they are no less powerful. They create the foundation for the plains themselves, quietly adding layers to the oceanic crust, and sometimes even forming new underwater mountains. Seamounts, those towering underwater mountains that rise from the abyssal plains, are often the result of long-dead or still active volcanic activity. These massive structures, some of which rise thousands of meters above the seafloor, can seem out of place in the otherwise flat landscape of the plains. But they are a crucial part of the geological processes that define the deep ocean. A seamount starts its life as an underwater volcano, and as it continues to erupt over millennia, layer upon layer of cooled lava builds up, forming a mountain that grows steadily toward the surface. While most never breach the ocean's surface, the presence of seamounts profoundly alters the topography of the abyssal plains, creating islands of elevation in a world defined by flatness. These volcanic seamounts do more than just alter the landscape. They create environments where life can thrive, despite the harsh conditions of the deep. As water flows over the peaks of seamounts, it creates currents that bring nutrients up from the depths, supporting a wide range of marine life. These seamount ecosystems stand in stark contrast to the surrounding abyssal plains, which are often barren and devoid of nutrients. In a sense, the volcanic activity that creates seamounts breathes life into an otherwise desolate environment, forming oases of biodiversity in the deep. It's as if these underwater mountains are the lungs of the abyssal plains, circulating energy and nutrients in a place where survival seems improbable. But it's not just the seamounts themselves that shape the abyssal plains. The volcanic activity beneath the surface constantly changes the very nature of the seafloor. The eruptions can create vast fields of hardened lava, known as pillow basalts, which spread out across the plains. These fields can stretch for miles, creating rough, rocky terrain that interrupts the smooth sediment that typically defines the abyssal plains. These newly formed volcanic landscapes are often inhospitable at first, but over time, they become integrated into the ecosystem, slowly covered by sediments carried by deep sea currents. This constant cycle of creation, destruction, and renewal means that the abyssal plains are never truly flat or featureless, but instead a patchwork of different environments shaped by volcanic forces. Seamounts also play a role in the geological stability of the abyssal plains. Their sheer size and mass act as stabilizing features, affecting the way tectonic plates move across the ocean floor. In some cases, seamounts are carried by the shifting plates towards subduction zones, where they are eventually dragged back into the Earth's mantle. This recycling process is part of the broader tectonic activity that governs the creation of new oceanic crust, and it underscores the interconnectedness of volcanic activity, seamounts, and the abyssal plains. The seamounts, which begin as eruptions on the seafloor, eventually become part of the cycle that fuels the continual movement of the Earth's crust. The significance of volcanic activity and seamounts on the abyssal plains is also felt in the way they influence deep-sea exploration. These towering formations, rising from the depths, serve as landmarks in an otherwise uncharted and uniform seafloor. For scientists navigating the vast expanse of the abyssal plains, seamounts are beacons of geological interest, offering clues about the forces at work beneath the ocean's surface. They provide natural laboratories for studying the formation of the Earth's crust, the effects of volcanic activity, and the unique ecosystems that develop in extreme environments. In a way, the abyssal plains are defined by these quiet, persistent forces of volcanic activity and seamount formation. The plains may seem like static, unmoving landscapes, but they are in constant flux, shaped by the power of the Earth's molten core. Each eruption, each rising seamount, reminds us that even in the deepest, most remote parts of the ocean, the planet is alive with movement. It's a slow, almost imperceptible transformation, but one that continues to reshape the abyssal plains, ensuring that these deep-sea environments are never truly still. The abyssal plains, far from the eyes of the world and shrouded in silence, have become a focus of deep-sea mining efforts as the demand for rare metals and minerals grows. These plains hold vast deposits of nodules rich in valuable materials like cobalt, nickel, manganese, and rare earth elements, which are essential for the production of electronics, renewable energy technologies, and even electric vehicle batteries. As industries continue to search for new sources of these resources, the abyssal plains offer a tantalizing, yet precarious, solution. However, the potential environmental consequences of mining these deep-sea treasures are profound and complex, raising questions about the balance between progress and preservation. Deep-sea mining is unlike any other form of resource extraction. The machines designed to operate on the abyssal plains resemble something out of a science fiction novel. Large, crawling devices that scour the seafloor for mineral-rich nodules, scooping them up and sending them to the surface. These machines are designed to work in one of the most extreme environments on the planet, operating under immense pressures and in complete darkness. But the extraction process is not as simple as gathering rocks from a desolate plain. The abyssal plains are home to delicate ecosystems that have evolved over millions of years, and disturbing the seafloor has the potential to cause damage that may never fully heal. The abyssal plains, though seemingly barren to the untrained eye, support a diverse array of life forms that thrive in the cold, nutrient-poor waters. From tiny microbial communities living in the sediments to strange, slow-moving creatures that rely on the scarce organic matter drifting down from the surface, life in the abyss is fragile and finely tuned to its environment. Deep-sea mining threatens to disrupt these ecosystems in ways we are only beginning to understand. The removal of nodules, which provide a habitat for certain species, can leave barren swaths of seafloor, wiping out entire communities of organisms. These ecosystems are incredibly slow to recover, if they recover at all, because the growth and reproductive cycles of deep-sea species can take centuries or even millennia. The sediment plumes created by mining operations add another layer of concern. As the mining machines disturb the seafloor, they kick up clouds of sediment that can travel vast distances through the water. These plumes can smother marine life, clog the gills of filter feeders, and block out the sparse light that some deep-sea species rely on. The plumes may also transport pollutants that were previously trapped in the seafloor, releasing them into the water column where they can spread and affect larger areas of the ocean. It's not just the immediate area around the mining site that's at risk. The impacts of these sediment plumes can ripple outward, affecting deep-sea ecosystems far beyond the boundaries of the mining operation. Another potential consequence of deep-sea mining is the release of carbon stored in the seafloor. The abyssal plains act as a massive carbon sink, trapping organic matter that slowly decomposes in the cold, dark environment. When the seafloor is disturbed by mining, this stored carbon can be released back into the water, potentially contributing to climate change. While the full extent of this impact is still being studied, it's clear that deep-sea mining could have unintended consequences for the planet's carbon cycle, adding another layer of complexity to an already fraught issue. The sheer remoteness of the abyssal plains adds to the difficulty of managing these potential impacts. Monitoring deep-sea mining operations is challenging due to the depth and inaccessibility of the sites. Unlike surface mining, where environmental degradation can be easily seen and measured, the effects of deep-sea mining often remain hidden, unfolding over long periods of time in places we rarely observe. This makes it difficult to hold companies accountable for the damage they may cause and complicates efforts to enforce regulations meant to protect deep-sea environments. For those involved in the mining industry, the allure of the abyssal plains is clear. The resources locked away in the deep sea represent a potential windfall for the global economy, offering access to materials that are becoming increasingly scarce on land. But the environmental costs of tapping into this resource are high, and the risks to the fragile ecosystems of the abyssal plains may outweigh the benefits. Mining companies often argue that technological advancements will minimize the environmental impact, but the reality is that even the most careful extraction methods could cause irreversible damage to ecosystems that have existed for millions of years in isolation. As humans, we are faced with a difficult choice. Do we forge ahead into the abyss, driven by our need for resources, or do we step back and consider the long-term consequences of our actions? The abyssal plains, vast and largely unexplored, represent one of the last true frontiers on Earth. What we decide to do with this frontier, whether to protect it or exploit it, will have ramifications not only for the creatures that inhabit the deep sea, but for the health of our planet as a whole. The delicate balance of life in the abyss could be tipped with just a few wrong steps, and once that balance is lost, it may be impossible to restore. The mining of abyssal plains is a reflection of a larger human dilemma: how to balance our insatiable need for progress with our responsibility to the planet. The deep sea, with all its mysteries and untapped potential, beckons us to explore further, to dig deeper. But it also reminds us that some places, and the life within them, are irreplaceable. The future of deep-sea mining will depend not just on the advancements in technology, but on the decisions we make today, decisions that will echo through the deep for generations to come. Far from the surface, where the sun no longer penetrates, the abyssal plains lie in darkness, seemingly untouched by human hands. Yet, even here, human activity has begun to seep into the deepest parts of the ocean, leaving behind a quiet but persistent mark. Pollution, carried down through the water column or scattered across the ocean floor, finds its way to these remote plains, affecting ecosystems that have evolved in isolation over millions of years. The waste and toxins we release on the surface don't simply disappear. They drift downward, settling in places where life is already scarce and fragile. Plastic debris, heavy metals, and chemical pollutants accumulate in the sediments, poisoning organisms that depend on the delicate balance of the deep-sea environment. The abyss, once thought too distant to be influenced by human actions, is proving to be more connected to the surface world than we had imagined. Microplastics, a ubiquitous pollutant that has been found in nearly every corner of the planet, now litter the abyssal plains. These tiny particles, often invisible to the naked eye, are carried by currents to the deepest parts of the ocean, where they settle into the sediment or are ingested by bottom-dwelling creatures. In a place where food is scarce, the ingestion of plastic can be deadly. Deep-sea organisms that have adapted to survive on the smallest scraps of organic matter mistake microplastics for food, leading to blockages, malnutrition, or even death. The plastics also carry toxic chemicals that leach into the surrounding environment, further contaminating the delicate ecosystems of the abyssal plains. Over time, these pollutants accumulate in the tissues of deep-sea creatures, slowly working their way up the food chain. What starts as a seemingly insignificant piece of plastic on the ocean surface ends up disrupting life in one of the most remote places on Earth. The impact of pollution on the abyssal plains isn't limited to plastics. Industrial waste, including heavy metals like mercury and lead, also finds its way into the deep ocean. These pollutants, often the byproducts of manufacturing, mining, and agriculture, are carried by rivers into the ocean, where they settle in the sediments of the abyssal plains. Once there, they can remain for centuries, slowly spreading through the environment. These toxic elements can affect the reproductive systems of deep-sea organisms, disrupt metabolic processes, and even cause genetic mutations. The creatures that live in the abyss are already under extreme stress due to the harsh conditions of their environment, and the addition of human-made pollutants adds yet another burden to their struggle for survival. But human activity in the abyssal plains doesn't stop at pollution. Deep-sea mining, a new frontier in resource extraction, threatens to reshape these ancient environments in ways we are only beginning to understand. The minerals and metals buried in the sediments of the abyssal plains, such as manganese, nickel, and cobalt, have become highly sought after as the demand for electronics and renewable energy technologies grows. Mining companies have begun to set their sights on these deep-sea deposits, developing technologies capable of scraping the ocean floor for these valuable resources. The extraction process, however, is anything but gentle. Massive machines disturb the sediment, uprooting organisms and destroying habitats that have taken millions of years to form. The abyssal plains, once considered untouched wilderness, are now at risk of becoming the latest victim of human exploitation. The environmental consequences of deep-sea mining are profound and long-lasting. The disturbance caused by mining operations creates sediment plumes that can travel for miles, smothering marine life in their path. These plumes can block out the faint light that some deep-sea species rely on for navigation, clog the gills of filter-feeding organisms, and spread toxins throughout the water column. Even once the mining operations have ceased, the damage to the seafloor remains. The nodules that are harvested by mining machines take millions of years to form, and once they are removed, there is no quick recovery. The ecosystems that depend on these nodules for shelter and sustenance are left without a home, and in many cases, they may never fully recover. The abyssal plains, for all their remoteness, are a critical part of the global carbon cycle. Organic matter from the surface slowly sinks to the bottom of the ocean, where it is buried in the sediments of the abyssal plains. This process helps to sequester carbon, preventing it from re-entering the atmosphere and contributing to climate change. However, human activity, whether through pollution or mining, disrupts this natural carbon sink. The disturbance of the seafloor releases stored carbon back into the water, potentially accelerating the process of global warming. In this way, the abyssal plains are not just passive victims of human activity. They are part of a larger system that helps regulate the health of the entire planet. By disrupting these deep-sea environments, we may be inadvertently tipping the balance of the Earth's climate system. The abyssal plains are often thought of as distant and disconnected from human life, but in reality, they are deeply intertwined with the health of the planet. The pollutants we release and the resources we extract from these depths have far-reaching consequences that extend beyond the deep sea. The creatures that live in the abyss, the ecosystems they form, and the role they play in regulating the Earth's climate are all part of a delicate balance that we are only beginning to understand. As we continue to push the boundaries of exploration and resource extraction, we are faced with a difficult question. How much are we willing to sacrifice in the name of progress? The abyssal plains may seem like a world apart, but their fate is tied to our own. What we do in the deep sea will echo back to us in ways we may not yet fully comprehend. In recent years, the abyssal plains have offered up some remarkable discoveries, shattering long-held assumptions about the deep ocean and revealing a world teeming with secrets. One of the most significant revelations came with the discovery of entirely new species of life forms, organisms that seem to defy what we once thought possible in terms of survival. These creatures have adapted to the extreme conditions of the abyss in ways that are as fascinating as they are unexpected. Some are slow-moving, bizarrely shaped, and appear to thrive in complete darkness and immense pressure. Scientists have uncovered microbial life capable of surviving on trace elements and chemical reactions alone, suggesting that life can persist in environments that would seem utterly inhospitable to us. The presence of these microorganisms has sparked curiosity about life's potential to exist on other planets, especially in similarly extreme environments, making each new species a clue in the broader search for understanding life beyond Earth. Equally surprising has been the discovery of vast biodiversity hotspots within what were once considered barren stretches of the abyssal plains. While these areas may seem like featureless deserts, researchers have found that certain regions are brimming with life. Hydrothermal vents and cold seeps, both relatively recent discoveries themselves, support ecosystems that are entirely independent of sunlight, drawing energy instead from the Earth's internal chemistry. These oases of life have reshaped our understanding of how ecosystems can form in complete isolation from the sun. What was once thought of as a sparse, almost lifeless landscape has now been revealed to be a patchwork of thriving biological communities. In some cases, researchers have observed species that are entirely new to science, with adaptations that allow them to survive not just the physical challenges of the deep, but the chemical complexity of these unique environments. Another area of discovery has focused on the geology of the abyssal plains, with advances in technology allowing scientists to map and study the ocean floor with unprecedented detail. High-resolution sonar and remotely operated vehicles have revealed the intricate topography of the seafloor, from towering seamounts to deep troughs and vast sedimentary expanses. This new level of understanding has shed light on the dynamic processes shaping the Earth's crust beneath the ocean. Sediment cores extracted from the abyssal plains have provided a window into the Earth's geological past, revealing layers of history that stretch back millions of years. These records of sedimentation offer insights into climate change, plate tectonics, and even past extinction events, each layer telling a story of the forces that have shaped both the planet and its oceans. In a particularly striking discovery, scientists have begun to unravel the mysteries of the carbon cycle as it plays out on the abyssal plains. It was once thought that the deep ocean was largely disconnected from surface processes, but recent research has shown how intimately linked these depths are to the global carbon system. The abyssal plains act as a major carbon sink, trapping vast amounts of organic material that slowly rains down from the surface. This process is vital to regulating atmospheric carbon levels, and it turns out that the organisms living in the abyss play a critical role in breaking down this organic matter. The discovery of how microbial communities and other organisms contribute to the sequestration of carbon has opened up new avenues for understanding global climate patterns and the ways in which the deep sea helps buffer the planet against climate change. There has also been growing interest in the discovery of deep-sea currents that flow across the abyssal plains, moving slowly but powerfully through the ocean's depths. These currents, which can take centuries to complete a full cycle, play a critical role in redistributing heat and nutrients throughout the ocean. The discovery of their patterns and influences has shifted our understanding of global ocean circulation, suggesting that even the most remote parts of the ocean are connected in ways we are only beginning to grasp. These slow-moving currents also transport sediments and nutrients, influencing the ecosystems of the abyssal plains in subtle but profound ways. Understanding these currents not only helps scientists piece together the puzzle of ocean circulation, but also has implications for how we understand climate change and its effects on the oceans. One of the more unexpected findings has been the accumulation of human-made materials in the abyssal plains. While it was known that pollution could reach these depths, the sheer quantity and variety of debris have been alarming. Researchers have found everything from plastic waste to chemical pollutants embedded in the sediment, much of it likely to remain for centuries or longer. These discoveries have provided a stark reminder of the far-reaching impact of human activity, even in the most isolated and untouched places on Earth. What we discard on the surface does not vanish, but instead travels to the deepest corners of the planet, where it mixes with the natural processes of the abyss. This realization has prompted new discussions about the global responsibility we have to protect not only the surface environments we are familiar with, but also the deep ocean ecosystems that are out of sight but still vulnerable to our actions. The study of the abyssal plains is still relatively young, and each new discovery seems to open the door to more questions. The deep ocean, once seen as a final frontier, is now being revealed as a critical piece in the larger puzzle of Earth's ecosystems. Every exploration, every dive, brings back data and insights that are reshaping how we think about the deep sea. With the continuing development of technology, scientists are gaining more access to these hidden worlds than ever before, and what they are finding is nothing short of extraordinary. The abyssal plains, once thought to be barren and lifeless, are proving to be full of life, history, and the clues we need to better understand the planet we call home. The abyssal plains, despite covering vast expanses of the Earth, remain one of its least explored frontiers. Their remoteness is the first and most obvious reason. These plains lie thousands of meters beneath the ocean's surface, in the darkest, coldest, and most pressurized environments on the planet. Reaching them is a technological challenge, requiring specialized equipment that can withstand the crushing pressures and icy temperatures of the deep ocean. Most of human exploration has naturally focused on environments closer to the surface, where sunlight, air, and the necessities of life are more accessible. The deep sea, particularly the abyssal plains, sits far beyond the reach of traditional exploration methods, which limits how often scientists can venture there. Even with advanced technology, the cost and complexity of deep-sea exploration are immense. Submersibles and remotely operated vehicles, ROVs, capable of diving to such depths are rare and expensive to operate. Each expedition requires a highly specialized team, expensive research vessels, and the kind of funding that few institutions can regularly provide. Unlike land-based exploration, where transportation and infrastructure are more straightforward, exploring the deep ocean involves navigating through miles of water before even beginning the real work. The logistics of sending equipment and researchers to such extreme depths and maintaining communication with them are daunting. This financial and logistical barrier has kept much of the deep ocean, including the abyssal plains, out of reach for consistent study. The abyssal plains themselves present unique challenges beyond their depth. The environment is harsh, unwelcoming, and seemingly featureless, which can make exploration feel like searching for a needle in an endless haystack. There are no obvious landmarks or points of reference, just vast stretches of flat seafloor. This monotony creates a different kind of challenge, one where the exploration seems to stretch endlessly without immediate reward. Unlike the vibrant coral reefs or dramatic seafloor ridges that captivate attention, the plains appear, at first glance, devoid of the intrigue that inspires most exploratory endeavors. Their very nature makes them easy to overlook in favor of other deep-sea environments with more immediate visual appeal or obvious scientific interest. Yet, beneath this seemingly barren surface, the abyssal plains hold complex ecosystems and geological structures that we are only beginning to understand. Their vast size contributes to the difficulty in exploration. Covering more than 50% of the Earth's surface, these plains are so expansive that it's impossible to study them thoroughly without sampling tiny portions at a time. This patchwork approach to exploration makes it difficult to piece together a comprehensive understanding of the abyssal plains as a whole. What's discovered in one section might not apply to another, adding to the mystery and unpredictability of these regions. The sheer scale is overwhelming, and even with modern technologies like satellite mapping and sonar, the fine details of these plains remain elusive. The lack of light in these depths also makes exploration more challenging. Sunlight never reaches the abyssal plains, leaving them in permanent darkness. This absence of light means that traditional visual methods of exploration, such as cameras, must rely on artificial lighting, which can only illuminate a small portion of the surrounding environment at a time. The creatures that live there, adapted to life in darkness, often move slowly or remain hidden, further complicating efforts to study them. This means that researchers are often working blind, piecing together clues in the dark. Unlike space, which offers vast views of distant galaxies, the deep ocean provides only glimpses of the immediate surroundings, making discovery a slow and painstaking process. Another reason the abyssal plains remain unexplored is that, until recently, they were thought to be relatively unimportant in the grand scheme of oceanography. The flat, sediment-covered expanses didn't seem to hold the dynamic forces of interest like the mid-ocean ridges or the dramatic underwater mountains. Only in the past few decades have scientists begun to understand the critical role these plains play in the global carbon cycle, ocean circulation, and deep-sea ecosystems. But despite this growing recognition, the abyssal plains remain in the shadows of more popular areas of study, simply because they don't fit the traditional image of a place teeming with life or geological activity. It's also worth considering that much of the deep sea has remained unexplored because it's simply so alien. The technology that allows us to explore space has progressed faster than that needed for the deep ocean, partly because of our cultural fascination with the stars and planets. Space offers a clear vision of exploration that feels boundless, whereas the deep ocean has always held a more mysterious, foreboding allure. It's only recently that humanity has begun to turn its attention inward, recognizing that the mysteries of our own planet's depths may be as profound as anything we might find among the stars. Yet, even as this shift happens, the ocean's most remote regions, like the abyssal plains, are still being explored at a pace that feels glacial compared to the rapid advancements in space travel. In many ways, exploring the abyssal plains feels like stepping into a forgotten world, one that's existed in isolation for millions of years, untouched by human hands. But the very qualities that make it so difficult to explore also make it one of the last true wildernesses on Earth. Each expedition to the abyss reveals a little more about the mysteries that lie in its depths, but the journey is slow, expensive, and requires a level of patience that few fields of study demand. While we've sent probes to the farthest reaches of our solar system, much of the abyssal plains remains a mystery, with only a fraction of its secrets uncovered. And perhaps it is this very remoteness that continues to inspire, offering the promise that no matter how much we think we've explored, the Earth still holds places that defy easy discovery. Abyssal plains, those vast, flat expanses at the bottom of the ocean, are a place where life seems almost impossible at first glance. Miles below the surface, in a realm without sunlight, it's easy to imagine nothing could survive. But the abyss is full of life, hidden and patient, living in ways we could barely comprehend. The biodiversity of these plains is a quiet testament to how life adapts, evolves, and finds its way in even the most challenging environments. Imagine a world where everything you need to survive trickles down from above. Tiny particles of organic matter, known as marine snow, descend from the upper layers of the ocean, settling on the abyssal plains like ash after a faraway fire. It's the only source of nourishment for many species here. These creatures, unseen and often misunderstood, have adapted to a life where every scrap is precious. Humans, in our own way, face scarcity too. And like the creatures of the abyss, we learn to adapt. Whether it's through cooperation, ingenuity, or sheer perseverance, we find a way, just as the organisms on the abyssal plains have done for millennia. But the abyss is not just a place of survival. It's a place of hidden connections, much like our own subconscious worlds. There are tube worms, which rely on symbiotic bacteria to convert chemicals from deep-sea hydrothermal vents into energy, a relationship that mirrors the way we rely on others to navigate the unseen pressures of life. These animals don't fight for the scraps that fall from above. They thrive on what others might ignore, forging bonds in a world that seems desolate. In some ways, it's a reflection of the human need for community, for relationships that sustain us when the world seems barren or cold. The biodiversity here is astonishing, even though the environment is so extreme. Giant squid, mysterious fish with bioluminescent bodies, strange creatures with transparent skin and unblinking eyes. They all live in a world so removed from ours it feels almost alien. Yet, in this strangeness, there is something familiar. The diversity of life on the abyssal plains is not unlike the diversity of human experience. We all find our way through the darkness, shaped by forces beyond our control, living in environments that often seem indifferent or hostile. But life persists, adapts, and creates beauty even in the most unexpected places. And perhaps that's the most profound contribution of the abyssal plains to the deep-sea biodiversity. It's not just a physical space where species live. It's a metaphor for resilience. Just as humans find ways to endure the pressures of life, the organisms of the abyss navigate theirs, creating a world rich in variety, complexity, and interdependence. Each organism, no matter how strange or small, plays a role in the balance of this fragile ecosystem. Without the abyssal plains, the deep sea would be a lonelier, less vibrant place, a reflection of how each human, with their unique strengths and weaknesses, contributes to the fabric of the world we live in. In the depths of the world's oceans, abyssal plains stretch out in every direction, but they aren't the same everywhere. The Atlantic, Pacific, and Indian Oceans all hold their own versions of these deep, dark expanses, each shaped by unique geological forces and histories. If you were to somehow travel across these hidden worlds, the differences would be subtle at first, like the unspoken nuances between cultures you only begin to grasp after spending time there. The Atlantic Ocean's abyssal plains are like the well-worn paths of an ancient city. Their formation has been influenced by tectonic activity, but because the Atlantic is younger compared to other oceans, its plains are smoother and more predictable. Sediment, mostly fine particles drifting from rivers and continents, has blanketed these plains over time, creating an almost featureless landscape. In a way, It's like the steady rhythm of life where things move at a consistent pace, where the familiar dominates, and surprises are few but meaningful when they happen. Life here reflects that, diverse, but not chaotic. The currents bring nutrients, and while the creatures that live here must endure the cold and darkness, they do so in an environment that, in geological terms, is relatively stable. The Pacific Ocean tells a different story. Its abyssal plains are more fragmented and interrupted by seamounts, trenches, and volcanic activity. The Pacific is older, and like a person who has lived through more storms, it bears the scars of time more visibly. The tectonic plates here are more active, reshaping the ocean floor, creating a more rugged and dynamic landscape. Life in the Pacific's abyssal plains is an adaptation to this unpredictability. There are creatures that thrive in the nutrient-rich areas around underwater volcanoes, where chemicals from the Earth's interior bubble up, creating life in places where it seems least likely. It's a world where change is constant, where the ground beneath you may shift without warning. It mirrors how some people live in environments full of unpredictability, where resilience is found not in steadiness, but in the ability to adapt swiftly to upheaval. The Indian Ocean's abyssal plains exist somewhere in between, geographically and metaphorically. They are less studied and understood, somewhat like a quiet person who moves through life unnoticed but is no less significant. These plains are influenced by both tectonic movements and the massive monsoon-driven sediment deposits from the surrounding continents. This ocean is bound by history and geography, with plains shaped by ancient currents and a geological past that includes the collision of the Indian and Eurasian plates. The biodiversity here is distinct, with species that have evolved in isolation, much like ideas or cultures that develop in the corners of the world where few outsiders venture. It's a place where you can sense the weight of history, the quiet forces that have shaped it over millions of years, creating a deep, enduring presence. Each of these oceans, like people from different walks of life, carries its own story in the abyss. The Atlantic offers stability, the Pacific challenges with unpredictability, and the Indian Ocean quietly reveals its complexity to those who take the time to look deeper. Life in these abyssal plains is a reflection of their environments, each shaped by the forces that govern them, finding ways to persist, adapt, and thrive in the face of challenges as different as the oceans themselves. It's not just a matter of location. It's about how each environment offers its own lessons in resilience and survival, just as the world offers us different paths shaped by the unseen currents of our own lives. The sedimentation process on abyssal plains is slow, almost imperceptible, like watching time pass in a place where nothing seems to change. Yet, layer by layer, the seafloor is shaped by this constant, quiet accumulation of material, much like how the experiences of a lifetime gradually settle into our minds, forming the foundations of who we are. The process begins at the ocean's surface, where the remains of dead organisms, tiny particles of dust carried by the wind, and fragments of minerals washed down from continents make their way into the water column. These particles drift down through the depths, taking months or even years to reach the bottom, where they come to rest on the abyssal plains. Once these sediments reach the seafloor, they slowly accumulate, creating a blanket that can be several kilometers thick in some places. This layer, made up of the remnants of life from above, carries with it the memory of everything that has happened in the ocean above: storms, volcanic eruptions, and even human activity. In a way, the sediment is like the subconscious, a repository for the forgotten moments and unnoticed details of life that still leave their mark. Over time, this accumulation shapes the seafloor itself, smoothing it out, covering any imperfections, and filling in gaps left by past geological activity. But this isn't a static process. Different regions experience sedimentation in different ways. Near the continents, sedimentation is often faster, as rivers and coastal erosion bring in large amounts of material. In the open ocean, far from land, the process is much slower, with only fine particles, marine snow, and the occasional plume of dust from the wind reaching these remote plains. Sometimes, volcanic ash or meteorite fragments add their own unique layers, creating moments of disruption in an otherwise steady process, much like how certain life events can leave a deep imprint in our personal histories. As these layers build up, they affect the seafloor in profound ways. The weight of the sediment can press down on the Earth's crust, altering its structure over time. In some places, the pressure can even cause the formation of methane hydrates, ice-like structures that trap gases within the sediment, which one day might release in a sudden burst, altering the ecosystem. The creatures that live on the abyssal plains are intimately tied to the sediment. Some burrow into it, finding shelter and food in the tiny particles that make up the seafloor. Others, like certain worms and microorganisms, rely on the chemical reactions that take place within the sediment to survive, extracting nutrients from what would otherwise be a barren environment. The sediment is both a protective blanket and a recorder of history. It shields the ocean floor from erosion, creating a stable environment for life to thrive. But it also carries the scars of past events. In some areas, layers of sediment can be disturbed by underwater landslides or tectonic shifts, revealing the deeper layers below. It's a reminder that even the most seemingly peaceful environments can hide great upheaval beneath the surface, much like how unresolved memories or emotions can emerge unexpectedly, shaping the present in ways we don't always anticipate. In this slow, relentless process of sedimentation, the abyssal plains change and evolve, though the changes may not be visible on the human timescale. Over millions of years, these layers of sediment build up into something substantial, forming a record of the Earth's history as told through the ocean. And just as each layer of sediment has its own story to tell, so too does the seafloor, slowly shaped by forces both subtle and profound, reflecting the ebb and flow of time itself. The abyssal plains are a place where survival depends on relationships, often ones we would never notice from the surface. Down there, in the cold and crushing darkness, every interaction matters. Species that inhabit this world aren't simply isolated. They live within a web of connections, each one relying on another in ways that seem fragile but are incredibly resilient. It's a quiet reminder of how interconnected everything is, even when it's invisible, even when we feel like we're drifting alone in the depths of our own lives. Some of these relationships are about survival in its most direct sense. Predators and prey play out their ancient dance, even in the stillness of the abyss. The giant isopods, for example, feed on whatever falls from above, whether it's a dead fish or the carcass of a whale that has sunk to the depths. These scavengers rely on the occasional bounty that drops into their world, much like how people sometimes depend on unexpected opportunities. But they're not alone in waiting for these moments. Other creatures, like hagfish or certain types of deep-sea shrimp, also feast on these rare offerings, creating a quiet competition that shapes their existence. Yet, it's not the kind of competition that leads to chaos. It's more like an unspoken understanding. There's enough for everyone if they take their share and leave the rest. Other relationships are more cooperative, though they might not seem so at first glance. Certain worms and bacteria in the sediment form partnerships that keep the ecosystem running smoothly. The worms burrow deep into the seafloor, creating tiny tunnels that allow oxygen to penetrate further into the sediment. This oxygen, in turn, fuels the bacteria living there, which break down organic matter into simpler compounds that other species can then use. It's an almost invisible exchange, one that benefits both, and it echoes the way humans form quiet partnerships in life. Small acts of support that may go unnoticed but sustain us in profound ways. Symbiosis runs deep in the abyssal plains, too. Some species rely entirely on others to survive in this desolate place. The deep-sea anglerfish, for example, hosts bioluminescent bacteria within the lure it uses to attract prey. The bacteria provide the light, while the fish offers them a home. It's a relationship that works because both give something to the other, and in a world where resources are scarce, such exchanges are critical. It's a reflection of how, in our own lives, we often find that the people we rely on the most are the ones with whom we share something deeper, a bond where giving and taking are balanced, and both are stronger for it. Even in the depths, there are parasites. Some species feed off others in ways that seem almost cruel, but are simply part of life down there. Certain isopods, for instance, attach themselves to deep-sea fish, feeding on their blood or body fluids. For the fish, it's a burden, but one they often endure, much like how some relationships in human life can be draining, yet unavoidable. These parasitic relationships may seem harsh, but they're another layer of the complex interactions that shape the abyssal ecosystem, where every creature plays its role, even if it's at the expense of another. There are also those that remain hidden, quietly existing alongside others without interfering too much. These creatures, like certain species of brittle stars or sponges, filter the water, feeding on microscopic particles and cleaning the environment as they do so. Their presence creates a healthier space for others to live in, even if they seem like passive participants. It's much like how some people in life bring peace and clarity simply by being there, by cleaning the emotional environment without ever drawing attention to themselves. In this vast, dark world, everything is connected by these fragile but enduring relationships. It's a place where cooperation, competition, and survival all blend together, creating an ecosystem that relies on balance. Just as in human life, the relationships on the abyssal plains define the existence of every creature, whether they're aware of it or not. There, in the silence of the deep, these connections play out endlessly, quietly shaping the lives of all who call the abyss home. The abyssal plains lie far below the surface, in a world so still and silent that you might think nothing ever stirs. But even here, in the deepest parts of the ocean, the waters above are always moving, and that movement carries its influence down to the plains. Ocean currents, born from wind and the Earth's rotation, sweep across the surface, but their energy eventually reaches the depths in subtle ways. It's like feeling the ripple of distant events in your life, ones that seem far removed but still manage to touch you in ways you can't always explain. At such great depths, the force of these currents is weakened, but they still have the power to shape the seafloor, stirring up sediment and guiding it across the plains. The abyssal currents, slow and methodical, carry tiny particles of sediment, fragments of rock, dust, and the remains of marine life, from one place to another. It's a process that happens over years, decades, centuries, quietly redistributing the ocean's memory, much like how the slow passage of time shifts our understanding of the past, scattering our memories and experiences into new patterns. In some areas, these deep currents create what are called abyssal drifts, large accumulations of sediment that build up over time. They act like deposits in the banks of the ocean, collecting material and subtly altering the landscape. These drifts are often long, gentle slopes, almost imperceptible unless you know what to look for. The sediment they carry is mostly fine, suspended particles that take years to settle. It's a reminder that, while change may happen slowly, it still transforms the environment in profound ways. Like the gentle currents of life, shifting our paths in ways we don't immediately notice, these deep-sea currents quietly reshape the abyssal plains. But the interaction between the plains and the currents is not just about movement. The plains themselves can influence the flow of water, directing it along certain paths. The topography of the plains, though mostly flat, still has subtle variations, and these variations can guide the currents, causing them to bend and twist in unexpected ways. When the water meets obstacles like underwater mountains or ridges, it slows down, sometimes depositing more sediment in those areas. Other times, the currents pick up speed as they are funneled through narrow channels, eroding the seafloor and carrying sediment away. It's a delicate balance, a push and pull between the steady force of the current and the quiet resilience of the abyssal plains. This process of sediment transport affects the ecosystem in ways that are both obvious and unseen. Some species rely on these currents to bring nutrients from distant parts of the ocean. Filter feeders, like certain types of sponges and sea cucumbers, depend on the fine particles carried by the water to sustain themselves. The sediment becomes part of the food web, much like how the small details of life, the passing conversations, the moments of kindness, become part of a larger narrative, feeding into something greater. At the same time, the shifting sediment can change the physical structure of the seafloor. In some areas, layers of sediment pile up, creating a soft, shifting surface. In other areas, the currents strip away the finer particles, exposing harder, more ancient rock beneath. This constant reshaping can alter the habitats of deep-sea creatures, forcing them to adapt to the changing conditions or move to new areas. It's like how we adjust to the shifting circumstances of our own lives, sometimes thriving in the changes, sometimes having to seek out new places where we can find stability. In the grand scheme of things, these interactions between the abyssal plains and ocean currents are slow and subtle, but they have a lasting impact. Over time, they create a landscape that is constantly in flux, though it may seem unchanging at a glance. The interplay of water and sediment mirrors the way unseen forces shape our own lives, gradually moving us in directions we might not expect, leaving behind traces of where we've been, and quietly molding the world beneath the surface. The deep sea has always captured the imagination, especially the abyssal plains, where life seems impossibly remote and alien. Myths and misconceptions about these depths often stem from our inability to truly grasp what lies so far below. People tend to imagine the abyssal plains as barren wastelands, devoid of life, or as places populated by monstrous creatures straight out of nightmares. In reality, the deep sea is neither lifeless nor ruled by horrors. It's a world shaped by survival, evolution, and delicate balance, far more nuanced than our surface impressions. One of the most persistent myths is that nothing can survive in such extreme conditions. It's easy to imagine the deep sea as too cold, too dark, too pressured for anything to live there. We associate life with light, warmth, and oxygen, and the abyssal plains offer none of these comforts. But life finds a way, as it often does in the most unlikely of places. The organisms that call these depths home have adapted to survive under crushing pressure and near-freezing temperatures. They have developed ways to thrive in the absence of sunlight, relying on other sources of energy like the nutrients that trickle down from the surface or the chemicals that seep from the Earth's crust. The truth is, these creatures are neither monsters nor miracles. They're just uniquely suited to their environment, much like how humans learn to adapt to the challenges of their own lives, drawing strength from unexpected places. Another common misconception is that the abyssal plains are untouched by human activity, that they are pristine worlds where the hand of man has never reached. This, too, is far from the truth. Even in these remote depths, traces of human activity are everywhere. Whether it's plastic debris that has sunk to the bottom, microplastics swirling in the water, or the impact of deep-sea mining. We like to think of the deep ocean as a world apart from our own, an unspoiled frontier, but in reality, the effects of our actions are felt even here. It's a sobering reminder that our reach extends further than we often realize, and that the choices we make on the surface ripple down into the depths, shaping environments we rarely think about. People also often imagine the creatures of the deep sea as grotesque and terrifying. The anglerfish, with its bioluminescent lure, and the giant squid, with its massive tentacles, have become icons of the deep sea's supposed horrors. We see them as monsters, strange and menacing, as if the abyssal plains are some kind of dark fantasy realm where nature turns sinister. But these creatures are not malevolent or monstrous. They're just as much a part of the natural world as the deer in a forest or the birds in the sky. Their unusual appearances are simply adaptations to their environment, not signs of something twisted or dangerous. Just because they don't look like the animals we're familiar with doesn't make them any less remarkable. It's easy to project fear onto the unknown, but in truth, these deep-sea creatures are wonders of evolution, each one a testament to life's ability to adapt to even the most extreme conditions. There's also a tendency to think of the abyssal plains as places where time stands still, where nothing changes over millions of years. The idea of eternal stillness is a comforting one, as if the deep sea could serve as a constant in a world that is otherwise in flux. But the deep sea is not frozen in time. The slow accumulation of sediment, the occasional volcanic eruptions, and the gradual shifting of tectonic plates all reshape the landscape, albeit on timescales that we can't easily perceive. Life itself evolves down there, just as it does everywhere else. While change may come more slowly in the abyss, it still happens, and the species that live there are constantly adapting to new challenges, whether it's a shift in food supply or a disturbance from human activity. The abyssal plains, like all parts of the natural world, are dynamic, even if the changes occur in ways that we cannot easily witness. The myths surrounding the deep sea reveal more about our own fears and misunderstandings than they do about the reality of life in the abyss. We project our anxieties onto the unknown, imagining it as a place of terror or isolation, when in fact it's just another part of the earth, full of life, interconnected with everything else. The deep sea, especially the abyssal plains, is not a distant, untouched realm but a part of our world, full of creatures that are neither monsters nor mysteries, but simply beings that have found a way to survive in one of the harshest environments imaginable. And just as we often misjudge or mythologize the unknown in our own lives, seeing it through a lens of fear or awe, we misunderstand the deep sea because it challenges our perceptions of what life is supposed to be. It's easy to think of the deep sea as a place untouched by time, where nothing ever changes in life, if it exists at all, is frozen in some ancient, eerie stillness. This idea of the abyssal plains as a forgotten realm where little more than eerie shadows and silence rule is far from the truth. Down there, in the darkness, life has not only adapted but flourished in ways that challenge our understanding of survival. The myth that the deep sea is static, unchanging, and devoid of life oversimplifies the complexities of this vast, unseen world. Just because we can't see what's happening doesn't mean nothing is happening. The deep ocean is a place where time works differently, yes, but it still moves forward, shaping and reshaping the lives of creatures in ways we can barely imagine. One misconception people hold is the idea that the creatures of the abyssal plains must be lonely, solitary beings, living in a desolate wilderness without connection to each other. The vastness of the deep sea conjures images of isolation, where a lone fish or strange creature drifts aimlessly through the water. But in reality, these beings are part of a complex and connected ecosystem, one that might not resemble the bustling life of a coral reef, but is no less intricate. There are scavengers that wait for the fall of a carcass from the higher waters, creatures that rely on one another in symbiotic relationships, and even communities that gather around hydrothermal vents, feeding off the warmth and minerals that seep from beneath the earth. It's not a lonely existence, but one defined by survival and interdependence, much like how people forge unseen connections in their own lives, even when it seems they're navigating the world alone. Then there's the idea that the deep sea is home to terrifying, monstrous creatures. Images of giant squid or anglerfish, with their bioluminescent lures, have cemented a fear of the deep, as if these creatures are the stuff of nightmares, waiting in the darkness to devour anything that comes near. But what we often fail to recognize is that these animals are no more monstrous than the creatures we find on land or in shallower waters. Their strange forms and adaptations aren't signs of danger or malevolence, but simply the result of millions of years of evolution, fine-tuned to the harsh conditions of the abyss. The glow of a light on an anglerfish's head, for instance, is a brilliant adaptation to a world without sunlight, helping it lure prey in a place where food is scarce. It's easy to misunderstand what we don't recognize, to project fear onto the unfamiliar, but these creatures are not menacing. They're remarkable. Another myth is that life on the abyssal plains is completely isolated from the rest of the ocean. People imagine the deep sea as a separate world, disconnected from the surface, as if it exists in a vacuum. But what happens above has a direct influence on what occurs below. The marine snow, a constant rain of organic material that drifts down from the upper layers, provides a steady source of nutrients for the creatures of the deep. Without it, life in the abyss would struggle to survive. The deep sea is far from being cut off. It's woven into the fabric of the entire ocean, reliant on the energy and life that originates much higher up. This interdependence is a reminder that nothing truly exists in isolation, not in the ocean and not in life. Finally, there's the misconception that the abyssal plains are immune to human impact, that they remain untouched by the hand of humanity simply because they lie so far from view. The deep sea seems distant enough to be protected from the waste and destruction we often associate with life on the surface. But plastic debris has been found in the deepest trenches, and deep-sea mining threatens to disturb fragile ecosystems that have remained undisturbed for millennia. The notion that the deep sea can escape the consequences of our actions is a dangerous myth. Just because something is out of sight doesn't mean it's beyond reach, and the delicate balance of life in the abyss is just as vulnerable to human influence as any other part of the planet. These myths and misconceptions stem from our desire to simplify what we don't fully understand. The deep sea, especially the abyssal plains, is more than a mysterious abyss. It's a place where life persists against incredible odds, where the creatures that thrive are not monsters but marvels of adaptation, and where human impact, though often invisible, can be deeply felt. In many ways, the misunderstandings we hold about the abyssal plains mirror the misunderstandings we sometimes have about the unknown in our own lives. Assuming danger where there is none, imagining isolation where connection exists, and believing that what we can't see doesn't matter. But just as the deep sea is full of life, complexity, and change, so too are the unseen corners of the world around us. Mapping and measuring abyssal plains is a task that involves far more than simply sending down a camera or taking a sample. The ocean's depths are vast, dark, and incredibly challenging to explore, much like trying to piece together the history of something ancient and hidden, where only the faintest clues remain. Scientists who venture into this unknown rely on technology to help them see what human eyes can never witness directly. The process begins not with sight but with sound, as sonar waves become the primary tool for feeling the landscape of the abyssal plains. Sonar, or sound navigation and ranging, works by sending pulses of sound down to the seafloor and measuring the time it takes for those pulses to bounce back. In a sense, it's like trying to map a landscape by listening to how sound echoes off its contours. The longer the sound takes to return, the deeper the ocean is at that point. By sending out thousands of these pulses, scientists can gradually build a detailed map of the abyssal plains. It's a slow and meticulous process, but the sound waves paint a picture of the topography that human eyes cannot. What emerges from the echoes is not just the flat expanse we often imagine, but a world full of ridges, valleys, and subtle variations that tell stories of ancient volcanic activity, or the movement of tectonic plates. But sonar alone isn't enough to reveal everything about the abyssal plains. Scientists also use remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, to explore these depths more directly. These machines, often equipped with high-resolution cameras, sensors, and sometimes even robotic arms, dive into the abyssal zone, venturing to places where human bodies could never survive. ROVs are controlled from ships on the surface, allowing scientists to guide them with precision, while AUVs are pre-programmed to explore specific areas on their own. It's almost like sending a probe into space, only here, the environment is crushingly dense and cold, and visibility is limited to whatever the machine's lights can illuminate in the black water. These vehicles collect data about the terrain, temperature, and composition of the abyssal plains, while also taking samples of the seafloor or capturing images of the creatures that live there. In addition to sonar and underwater vehicles, scientists also rely on satellites to help with mapping the ocean. While satellites can't see through the water, they can detect minute changes in the sea surface that correspond to the topography below. For instance, a seamount, or underwater mountain, will create a small bulge on the ocean surface due to the gravitational pull it exerts. By measuring these subtle variations, satellites contribute to creating broader maps of the ocean floor. It's a reminder that, even when we can't see something directly, its influence can still be felt in ways we might not expect. The sediment that covers the abyssal plains also holds secrets that can only be uncovered through core sampling. This involves sending down long tubes to extract cylindrical samples of sediment from the seafloor. These cores are like time capsules, preserving layers of history that stretch back millions of years. By studying the different layers of sediment, scientists can learn about past ocean conditions, the types of life that once existed there, and even how climate change has affected the deep sea over time. It's a process that requires patience and a delicate touch, much like peeling back the layers of a complex story to understand what has shaped the present. There's a sense of awe that accompanies the work of mapping the abyssal plains, a feeling of uncovering something primordial and mysterious. The ocean is still one of the least explored places on Earth, and each new map, each new measurement, adds to our understanding of a world that remains largely hidden. But for all the advanced technology used, there is still much we don't know, many areas that remain blank spots on our maps. And perhaps that's part of the draw, this sense that, even with all our tools and machines, the ocean continues to hold secrets just beyond our reach. Scientists, in their pursuit of understanding, are like explorers of an alien landscape, driven not just by curiosity, but by the belief that there's always more to discover. The abyssal plains may seem far removed from the world most of us know, but the more we learn about them, the more we realize how interconnected everything truly is. The deep sea is not a distant, forgotten realm. It's part of our planet's story, and mapping it brings us closer to understanding the whole. Abyssal plains, often overlooked in the grand narrative of Earth's surface, offer a profound window into the planet's geological history, much like reading the hidden pages of an ancient, forgotten book. These vast, flat expanses of the deep ocean floor, covered in fine sediment, serve as a canvas upon which the Earth has quietly inscribed its secrets. Beneath the stillness of these plains lies a dynamic record of volcanic eruptions, tectonic shifts, and sedimentary processes that have unfolded over millions of years. As sediment slowly drifts and settles from above, it forms layers, each one a chapter in Earth's evolving story, capturing moments of upheaval and calm, of creation and destruction. In these layers, the evidence of ancient volcanic activity is found, where mid-ocean ridges have spewed molten rock, shaping the ocean floor. The abyssal plains, though remote and seemingly untouched, bear the scars of these primal forces. As the Earth's crust moves and spreads, it drags the remnants of the past with it, pulling tectonic plates across the ocean floor in a slow, steady dance. This movement leaves behind magnetic signatures in the rocks, revealing how the planet's magnetic field has flipped and changed throughout history. In this, the abyssal plains become a silent witness to Earth's shifting face, recording the unseen movements below our feet that shape the continents and oceans. But there is more than just the geological past embedded in these plains. The fine, dusty sediment contains microscopic remains of ancient life, plankton, shells, and organic matter that once thrived in the sunlit waters above. Their slow descent to the abyssal plains creates a rich, biological archive that tells of life's endurance and adaptation through changing climates, ice ages, and mass extinctions. These traces offer a glimpse into the fragile balance of life and the ways it has survived Earth's violent past. For humans, Peering into the depths of the abyssal plains is like discovering the hidden depths of our own history. We may stand on solid ground, but the earth beneath us is far from still. It is constantly moving, evolving, and reshaping itself. These plains remind us that there is more to our world than what we can see, that the Earth's past is written in places few will ever go, in the deep, cold expanses of the ocean floor. Studying them is like trying to make sense of a dream, a fleeting vision of how things once were, and how they have come to be. Each sample, each core pulled from the abyssal plains, is a puzzle piece that helps us understand not just the geological past, but the interconnectedness of life, death, and the forces that shape the world. Through these quiet, unseen landscapes, we begin to understand the deeper currents of Earth's story, one that runs far below the surface yet touches every part of our existence. Abyssal plains, the vast, flat expanses at the bottom of the ocean, represent one of the most mysterious realms on Earth, an alien world within our own. Though they cover more than half of the Earth's surface, these plains remain largely unexplored, stretching out in a dark, silent void. Our encounters with them are brief and fragmented, like trying to piece together a memory from a dream that fades as soon as you open your eyes. This remoteness makes them elusive, and what we don't know about them feels almost infinite. The questions we ask about abyssal plains, while rooted in curiosity, often come up against the sheer limitations of our technology and understanding, as though the deeper we venture, the more the abyss seems to retreat into shadow. One of the biggest mysteries involves the life forms that inhabit these dark plains. We know there is life down there, but the scale and complexity of ecosystems that could thrive at such depths are largely unknown. What we do know suggests there are entire worlds of creatures we have yet to meet, organisms that live beyond the reach of sunlight, enduring pressure and cold that would destroy most forms of life on the surface. These creatures may even possess adaptations and survival strategies we can hardly imagine. The deep ocean seems like a kind of parallel existence, where evolution has quietly continued, uninfluenced by the forces that shape life in the shallow waters and on land. It's not just about discovering new species. It's about how these species live, how they have learned to navigate a world of endless night. Then there's the question of how the abyssal plains themselves have formed, and what forces continue to shape them. Underneath all that sediment and rock, there might be geological processes we have barely scratched the surface of, massive movements of tectonic plates, unseen volcanic activity, or perhaps even vast, slow shifts in the ocean floor that could reshape what we think we know about the Earth's crust. Scientists believe there are minerals and resources embedded deep within the plains, but understanding the distribution and impact of such resources may be far more complex than just drilling for oil or gas. There is a tension between curiosity and exploitation. Some of the unknowns we face aren't just about what's physically down there, but how our future actions could disturb the balance of a place that has existed in near-perfect isolation for millions of years. Humanity's connection to these places is tenuous at best, often reduced to brief glimpses through submersibles and unmanned vehicles. The remoteness of the abyssal plains creates a kind of psychological barrier, as if this world is so far removed from our own that we struggle to even conceptualize it. The questions we ask about this environment, about its inhabitants, its ecosystems, its mysteries, aren't just about science or discovery. They are also about us, about our drive to explore and understand places we can never truly inhabit. The abyssal plains are an invitation to confront our limitations, both technological and existential, reminding us that for all our knowledge, there are still corners of the Earth we can barely touch, let alone comprehend. In a way, what we don't know about the abyssal plains feels like a reflection of our own unanswered questions, the uncharted parts of the human psyche. Just as we peer into the abyss hoping to uncover something about this hidden world, we're also looking inward, searching for the deeper truths that still evade us, just out of reach. These plains are both a physical place and a metaphor, a space where the unknown, the unseen, and the untouched wait, suspended in the deep silence of the ocean floor. Abyssal plains and ocean trenches exist in a delicate interplay, each part of the deep-sea landscape that forms the unseen foundation of our planet. While the abyssal plains stretch out like vast, featureless deserts, ocean trenches carve into them like immense scars. These trenches, the deepest parts of the ocean, seem like wounds in the Earth's crust, reminders of the tremendous forces at work beneath the surface. Abyssal plains, in contrast, are formed by sediment drifting down over eons, slowly burying the jagged edges of the ocean floor, smoothing it into something deceptively calm. And yet, Even in their stillness, these plains are connected to the restless geological activity of the trenches. Trenches are created by the collision and subduction of tectonic plates, where one plate is forced beneath another, creating an intense downward plunge. Abyssal plains, though relatively flat, are often adjacent to these dynamic regions. They might seem separate, but they are bound to the same tectonic movements, shaped by the slow grinding of the Earth's plates. The plains, despite their calm appearance, owe much of their existence to this violent, unseen activity. Without the trenches and the geological processes they represent, the abyssal plains might not exist as they do. The trenches pull the Earth inward, and the plains quietly collect the debris of this ongoing process, like dust settling after a long storm. It's a cycle that plays out over millennia, almost imperceptible to human eyes, yet endlessly shaping the world beneath the waves. The deeper you go, the more these features feel intertwined, each one telling a different part of the same story. Ocean ridges, the opposite of trenches, rise up where plates are pulling apart, creating new crust that slowly spreads out and eventually sinks beneath the weight of sediment, contributing to the abyssal plains. Hydrothermal vents along these ridges spew minerals into the water, providing nutrients that feed ecosystems unlike anything else on Earth. These ecosystems, too, find their way to the plains as creatures migrate from ridge to plain, venturing into the wide, open depths. The abyssal plains may seem passive, but they are shaped by the same forces that create ridges and trenches, participating in the grand geological drama that plays out in the depths. Even the deep-sea volcanoes, called seamounts, that occasionally punctuate the abyssal plains are part of this story. Rising from the flat plains like mountains in a desert, they hint at the unseen tectonic forces beneath. They stand as reminders that even the flattest, most featureless parts of the ocean floor are not as tranquil as they seem. The seamounts provide homes for life and anchor points in an otherwise desolate environment. In a sense, the abyssal plains are a canvas, and the ridges, trenches, and seamounts are the brushstrokes, each adding depth, texture, and meaning to the ocean's deep seascape. This entire landscape, plains, trenches, ridges, and seamounts, feels alive, even though it moves on a timescale that makes it hard for us to grasp. It's a world defined by contrasts: the vast emptiness of the abyssal plains and the violent descent of the trenches, the slow accumulation of sediment and the explosive activity of undersea volcanoes. As humans, we stand on the edge of this abyss, knowing that these geological features, though remote and untouchable, influence everything from the chemistry of the oceans to the long-term stability of the planet. They remind us of our smallness in the face of time and nature, of how the Earth itself moves and breathes, even in places we may never fully understand. Beneath the endless sediment of the abyssal plains, there are resources that have stirred the curiosity of scientists and corporations alike. These plains are rich in mineral deposits, with vast fields of polymetallic nodules scattered across the ocean floor. These nodules, small dark lumps formed over millions of years, contain valuable metals like manganese, cobalt, nickel, and copper, elements essential to modern technology, from smartphones to electric vehicles. There are also deposits of rare earth elements hidden deep in these plains, crucial for building the magnets and batteries that power our world. It's a treasure trove, sitting there quietly beneath miles of ocean, waiting to be unlocked. The sheer scale of these deposits is staggering, and for a world hungry for resources, they hold the promise of a new frontier in mining. But it's not as simple as sending machines down to scoop up the riches of the deep. The abyssal plains are not barren wastelands. They are home to unique ecosystems, much of which remains unexplored. Tiny, delicate organisms live within the sediment, and complex food webs stretch across these plains. Mining these resources would mean disturbing a world that has evolved in isolation for millions of years, where even a slight disruption could cause irreversible damage. It's not just about what we can take from the abyssal plains, but about what we destroy in the process, things we haven't even fully discovered yet. The ethical question looms large. How do we balance the demand for resources with the responsibility of preserving a part of the planet that has remained untouched for so long? There is something unsettling about the idea of digging into this silent, hidden world for the sake of convenience. The technology that promises to improve our lives could come at the cost of wiping out life forms we've never encountered. The allure of those mineral riches is powerful, especially as resources on land become scarcer and harder to access. But there's an undeniable sense of trespassing. When you look at the abyssal plains, you're looking at a place that exists beyond human influence, a space where nature has had free reign. There's a quietness to it, a kind of purity, and it feels like an ethical line is crossed when we begin to think about it as just another place to extract wealth. The question isn't just about damage to ecosystems, though that is part of it. It's also about long-term consequences. What happens when we start mining in the deep ocean? Does it open the door to a new era of exploitation, where even the most remote parts of the Earth are no longer beyond human reach? And once we start, how do we stop? The ethical dilemma deepens when we realize that the abyssal plains could hold the answers to scientific questions that have gone unanswered for centuries. By disturbing these regions, we could lose invaluable data about Earth's history, climate change, and the origins of life itself. In the end, it feels like a balance must be struck between need and restraint, between human ambition and humility. The resources of the abyssal plains are tempting, and the benefits to technology and industry are undeniable. But the costs, both ecological and ethical, must be considered just as carefully. These plains, silent and remote, force us to confront what kind of stewards we want to be of the planet. The abyssal plains hold within them a subtle record of the Earth's deep, ancient movements, shaped by forces so gradual they almost escape human perception. These vast, flat expanses, stretching beneath the ocean's surface, are formed largely by the accumulation of sediment over millions of years. But underneath that layer of stillness lies the evidence of a restless Earth. The plains are not simply the result of random deposits, but are shaped by the slow, deliberate motion of tectonic plates as they drift, collide, and pull apart. It's a process that is happening beneath our feet all the time, yet we rarely feel its full force. Tectonic plates are constantly on the move, shifting imperceptibly in a dance that has been going on since the Earth's crust first solidified. As plates separate along mid-ocean ridges, new ocean floor is created, pushing outward and forcing older sections of the ocean floor to spread toward the edges, where they slowly sink back into the Earth at subduction zones, often creating trenches. The abyssal plains lie between these active areas, like the quiet aftermath of these powerful movements. They are, in many ways, the final resting places for pieces of the Earth's crust that have been carried along by tectonic forces. The plains become blank canvases, slowly covered over time by the fine particles that drift down through the water column. The slow movement of the plates also leaves behind subtle ridges and fractures in the seafloor, some of which are buried beneath layers of sediment. These features are like scars, traces of a time when the crust was more dynamic, when volcanic activity and seafloor spreading were actively shaping the landscape. Over millions of years, these once active regions grow quiet, their jagged edges softened by the relentless rain of sediment. The abyssal plains, then, are like a palimpsest, where the history of tectonic activity is written, erased, and written over again. But the movement of the plates isn't always gentle. Occasionally, these slow processes give way to sudden bursts of energy in the form of earthquakes or volcanic eruptions, reminding us that the tectonic forces at play are still very much alive. Even the abyssal plains, which seem so static, can be reshaped by these events, as deep-sea volcanic eruptions spill lava onto the ocean floor, or as tectonic shifts cause the seafloor to crack and buckle. What seems peaceful is often only temporarily so, and the Earth's plates continue their endless journey beneath the oceans, leaving traces in their wake. Over geological time, the abyssal plains reflect the very essence of this slow, inexorable movement. They are places where time itself feels stretched out, where the actions of the Earth's tectonic plates unfold on a timescale far beyond human comprehension. It's hard to grasp that what seems like stillness is actually the result of processes that have been at work for hundreds of millions of years. We, standing on the surface, experience the world in moments, in days and years, but the abyssal plains remind us that the Earth moves to its own rhythm, one that we can only glimpse in the faint echoes of the past. Abyssal plains, seemingly so far removed from the surface world, are not untouched by the effects of climate change. Though these vast, deep expanses lie miles beneath the ocean, they are linked to the surface by intricate biological, chemical, and physical processes that are slowly but surely being altered by a changing climate. One of the most profound impacts comes from the warming of ocean waters. As the planet heats up, so do the oceans, and even though it takes longer for that warmth to penetrate to the deepest depths, the abyssal plains are beginning to feel the effects. Warmer water affects ocean currents, the very lifeblood that connects the deep sea with the rest of the ocean. These currents are critical for transporting oxygen and nutrients to the abyssal plains, and any disruption to this delicate system could starve the deep-sea ecosystems that thrive in the darkness. But it's not just about temperature. Climate change is also altering the composition of the oceans. Increased levels of carbon dioxide in the atmosphere are being absorbed by the oceans, making them more acidic. This change in the ocean's chemistry doesn't stop at the surface. It filters down into the deepest parts of the sea, slowly acidifying the waters that bathe the abyssal plains. The creatures that live in these environments are adapted to incredibly stable conditions, cold temperatures, low light, and very specific chemical balances. Even a slight shift in acidity can affect how they survive, how they reproduce, how they interact with their environment. And because life down there moves at such a slow pace, it's unclear how quickly, or if, these ecosystems can adapt to such a fundamental change in their environment. One of the more hidden consequences of climate change is its impact on the carbon cycle. The abyssal plains play a critical role in this cycle, acting as a massive carbon sink. Organic material from the surface, from tiny phytoplankton to the carcasses of larger creatures, drifts down to the seafloor, where it becomes part of the sediment. This process locks carbon away, essentially removing it from the atmosphere for long periods of time. But as ocean ecosystems are disrupted by warming temperatures and acidification, this cycle is changing. Phytoplankton blooms are shifting, fish populations are migrating, and the overall health of ocean ecosystems is deteriorating. All of these changes affect the amount of organic material that makes its way to the abyssal plains, potentially reducing the efficiency of the deep-sea carbon sink and weakening one of the Earth's most important natural defenses against climate change. There is also the issue of melting ice. As polar ice caps and glaciers melt, they release not only freshwater but also ancient organic material into the oceans. This can increase sedimentation in some areas, burying parts of the abyssal plains under layers of silt and debris. This influx of material could smother ecosystems that rely on the steady, slow accumulation of nutrients. At the same time, the changing patterns of ice melt are altering the global ocean currents, which in turn could disrupt the delivery of oxygen and food to the deep ocean. It's a cascade of changes that, while happening gradually, could have profound effects on the abyssal plains over time. What makes all of this so unsettling is the sense of invisibility. We don't see the abyssal plains, and their transformations are happening in a place far beyond human reach. Yet, these changes, driven by climate forces above, are a reminder that no part of the planet is isolated. The deep sea, so seemingly distant from our everyday lives, is intricately connected to the surface world, and the impacts of climate change are creeping even into the darkest, most remote corners of the Earth. It's a sobering thought that even here, miles beneath the waves, the consequences of our actions are slowly unfolding, shaping a world that most of us will never see, but that is every bit as fragile as the one we live in. Bioluminescence in the species that inhabit abyssal plains is nothing short of a survival art, a way to navigate a world that exists in perpetual darkness. Down there, where sunlight never penetrates, creatures have developed this extraordinary ability to create their own light, a glow that seems almost supernatural to us on the surface. But for the beings that live in these depths, bioluminescence is as essential as breathing. It serves many purposes, all of them tailored to the harsh environment of the abyss, where survival is a constant challenge. One of the primary ways bioluminescence functions is in communication. For creatures living in the abyssal plains, where visibility is limited to the occasional flash of light, bioluminescence is a way to signal to others of their kind. Whether it's to attract a mate, establish territory, or coordinate group behavior, light becomes a language. Certain species of fish, for instance, use bioluminescence to create intricate displays that can only be seen by others capable of perceiving their specific wavelengths. These creatures live in a world where a single flash of light can convey a message as clearly as any spoken word. And in a place where resources are scarce and survival is uncertain, the ability to communicate efficiently can mean the difference between life and death. Predators, too, have turned bioluminescence into a tool. Some species use light as a lure, creating small, glowing appendages that mimic the appearance of prey. This illusion draws unsuspecting creatures closer, where they can be quickly captured and consumed. The anglerfish is perhaps the most famous example of this, using a bioluminescent lure that dangles from its head, tempting smaller fish to swim right into its waiting jaws. It's a clever strategy in a place where energy must be conserved and hunting can take on a cat-and-mouse quality, where patience is rewarded with the brief but deadly burst of bioluminescent light. In these moments, light is not just a tool, it's a weapon. For other species, bioluminescence functions as a defensive mechanism. In a world with so few hiding places, creatures need to get creative to avoid becoming someone else's meal. Some animals emit sudden bursts of light to startle predators, buying themselves precious seconds to escape. Others release bioluminescent particles into the water, creating a glowing cloud that confuses and distracts their pursuer. These displays are not just about avoidance, but about survival in a place where any advantage, no matter how small, can keep you alive for one more day. Even the deep-sea shrimp uses bioluminescence as a kind of escape tactic, ejecting glowing substances into the water like a decoy, while it makes a quick getaway into the surrounding darkness. But bioluminescence isn't just about interaction between species. For some creatures, it plays a role in navigating the abyssal plains themselves. The plains are vast and featureless, with no landmarks to guide the way. In such an environment, a flash of light can be a way to map the surroundings, to detect the faintest shapes in the water, or even to sense nearby movement. Certain jellyfish and squid produce light patterns that help them feel out their surroundings, creating brief moments of clarity in the otherwise endless dark. It's as if these creatures are lighting up their world moment by moment, adapting to the sheer emptiness around them with nothing but a flicker of their own making. The beauty of bioluminescence lies in its adaptability, in how it meets the unique demands of life on the abyssal plains. It's not just a trick of nature, but a response to the deep-sea environment, a way to thrive in a place where conventional rules of survival don't apply. In this world, where darkness is absolute and life seems to defy all odds, bioluminescence becomes a form of expression, of defense, of survival, and even art. It turns the deep ocean into a place of quiet light shows, where every glow carries meaning and every flash has a purpose. And as we learn more about the creatures that live there, it becomes clear that this phenomenon is not just fascinating, but deeply personal to the survival of each species that calls the abyss their home. Seafloor spreading plays a quiet but pivotal role in the story of the abyssal plains. It's the engine that drives the slow creation of these vast, flat stretches of the ocean floor, a process that begins at the mid-ocean ridges, where tectonic plates are pulling apart. There, molten rock from deep within the earth rises to the surface, solidifying as it cools to form new oceanic crust. This fresh crust is like a newborn piece of the planet, rough and raw, slowly pushed outward by the relentless force of seafloor spreading. Over millions of years, this new seafloor moves away from the ridges, inching toward the outer edges of the ocean basin, where it will eventually sink back into the earth at subduction zones. But in that long journey, it becomes the foundation for the abyssal plains. As the crust moves away from the ridges, it cools and sinks, creating the depressions that will eventually be filled by sediments. The abyssal plains are, in a sense, the final resting place of the seafloor, areas where the movement of the Earth's plates has calmed, and where the surface has been blanketed by layers of sediment carried down through the water over time. Without seafloor spreading, these plains wouldn't exist in the same way. It's a slow process, almost impossibly slow by human standards, but over millions of years, it sculpts the deep ocean floor into the flat, featureless expanses we call abyssal plains. But seafloor spreading isn't just about creating space for sediments to accumulate. It's also a reminder of the dynamic nature of the Earth beneath the ocean. Even in the deepest, darkest parts of the sea, far from the ridges where the crust is born, you can feel the echo of that process. The crust beneath the abyssal plains was once part of that mid-ocean ridge, fresh and new, full of volcanic activity. Over time, it's been carried away from that fiery birthplace, cooling and hardening as it goes, until it becomes part of the vast, quiet landscape we see today. It's easy to think of the abyssal plains as static, but in reality, they're part of a much larger and ongoing cycle of creation and destruction that plays out beneath the ocean's surface. Seafloor spreading also ties the abyssal plains to the greater tectonic story of the planet. The crust that makes up these plains isn't permanent. It's always moving, always changing. As it spreads, it gets older, eventually reaching the edges of the ocean basin, where it's pulled back into the Earth's mantle in a process known as subduction. In this way, the abyssal plains are just one chapter in the life of the seafloor, a middle ground between the birth of new crust at the mid-ocean ridges and the destruction of old crust at the subduction zones. They are part of this grand, cyclical process that keeps the surface of the Earth in constant motion, even though it happens on a timescale so vast we can hardly comprehend it. In this context, seafloor spreading isn't just a geological process. It's a reminder of the Earth's resilience and restlessness. The abyssal plains, flat and quiet though they seem, are shaped by forces that are both ancient and ongoing. Forces that continue to mold the planet in ways we are only beginning to understand. Seafloor spreading is a fundamental part of that story, slowly pushing the Earth's crust outward, creating new landscapes, and in the process, giving life to the abyssal plains, the deep and mysterious parts of the ocean that stand as silent witnesses to the slow, steady movements of the Earth. Organic matter from the surface is a lifeline to the abyssal plains, a connection that bridges the vibrant world above with the dark, remote depths below. Life on the surface of the ocean is abundant, fueled by sunlight and the energy it provides to tiny organisms like phytoplankton. But in the abyssal plains, where sunlight never reaches, there's a quiet reliance on what drifts down from the world above. Organic material. Everything from dead fish, plankton, and marine snow, to the occasional larger carcass, slowly sinks through the water column. It's a long, slow journey, and by the time it reaches the abyss, it's been reduced to a fine rain of particles, tiny fragments of life that still hold enough energy to sustain the creatures waiting far below. For the life that exists on the abyssal plains, this organic matter is precious. The creatures that live in this vast, dark expanse have adapted to the scarcity, knowing that each morsel that reaches them could mean the difference between life and starvation. Deep-sea creatures are often highly specialized. Their bodies adapted to make the most out of the small amounts of food that trickle down from above. Some, like the giant isopod, scavenge the seafloor, feasting on whatever organic debris they can find. Others, like certain types of fish and sea cucumbers, sift through the sediment, extracting the nutrients left behind in the slow accumulation of particles. In this ecosystem, nothing is wasted. The impact of organic matter on the abyssal plains goes beyond just feeding the creatures that live there. It also fuels entire ecosystems, creating a delicate balance that's sustained by the constant, if slow, arrival of nutrients from above. Even the bacteria living in the sediment rely on this rain of organic material, breaking it down into simpler compounds that can be absorbed by other organisms. This cycle, though it moves at a glacial pace compared to the surface world, is essential for maintaining life in such a hostile environment. Without it, the abyssal plains would be barren, lifeless deserts, devoid of the strange, resilient creatures that call it home. But this flow of organic matter is not always steady. It fluctuates with changes on the surface. Seasons, climate shifts, and even human activity can alter the amount and type of material that reaches the abyss. In some areas, when surface productivity is high, a burst of organic material rains down, creating a temporary feast for the creatures below. At other times, when surface conditions are less favorable, the abyssal plains must endure long stretches of scarcity. These fluctuations shape life in the deep ocean, where species have learned to adapt to feast or famine, storing energy during times of abundance and slowing their metabolisms during lean periods. There's something humbling about this connection between the surface and the abyss. It reminds us that even in the most remote, untouched parts of the planet, life is connected in ways we often overlook. What happens on the surface, whether it's a bloom of plankton, the death of a whale, or the slow accumulation of debris from a distant shoreline, can ripple down to the very bottom of the ocean, nourishing creatures that live in complete darkness. The abyssal plains, though far removed from the world we know, depend on this unseen relationship, surviving on the remnants of a distant world they can never reach. Researchers who venture into the extreme depths of the ocean face challenges that seem almost insurmountable. The abyssal plains lie beneath miles of water, in a realm of crushing pressures, freezing temperatures, and complete darkness. For scientists, every dive into this environment requires not only the best technology available, but also a mindset that embraces patience, perseverance, and a willingness to contend with uncertainty. Conducting experiments here is a delicate balance between curiosity and the limitations imposed by one of the most hostile environments on Earth. The immense pressure is one of the first obstacles. At these depths, the weight of the water above exerts a crushing force on anything that descends into it. For humans, unprotected, the pressure would be lethal. Even for machines, this environment is unforgiving. Any equipment sent down must be specially designed to withstand pressures that would crumple steel or shatter glass. Submersibles, remotely operated vehicles, ROVs, and specialized landers are built with reinforced materials, sometimes titanium or thick synthetics, to endure the extreme conditions. Engineers work closely with marine biologists and oceanographers to create these machines, crafting vehicles that can not only survive the descent but also perform delicate tasks, like collecting samples or taking measurements, with precision. The cold is another constant companion. The water temperature in the abyss hovers near freezing, and the machinery researchers use must be capable of functioning in this deep freeze. Electronics, batteries, and mechanical parts can seize up in these conditions. To counter this, equipment is insulated and often has heating elements to keep key components warm enough to operate. Yet, these solutions can only go so far. The deep sea is a place where malfunctions are common, where a piece of equipment that worked perfectly on the surface can fail after days of exposure to the abyssal cold. And then there's the darkness. The abyssal plains are enveloped in perpetual night, making visibility nearly impossible without artificial lighting. This isn't just a logistical issue. Lighting can disturb the very creatures and ecosystems researchers are trying to study. The faintest glimmers of artificial light might seem like blinding flares to species adapted to total darkness, altering their behavior and skewing experimental results. Researchers must strike a delicate balance, using low-light cameras and specialized lighting systems that minimize disruption while still allowing them to observe and record what's happening. It's a careful dance, trying to see without being seen, and it requires a great deal of creativity and precision. Then, there's the challenge of time. Getting to the abyssal plains takes time, sometimes hours just to descend, and each trip is costly, both in terms of money and effort. Once at the bottom, there is often only a small window for conducting experiments before equipment must be retrieved and brought back to the surface. The delicate work of gathering samples, whether it's sediment, water, or biological specimens, must be done quickly and efficiently, and any error or malfunction can mean the loss of an entire mission's worth of data. Researchers know that every moment counts and must be prepared for the possibility that months of planning can be undone in an instant by a technical glitch or an unexpected environmental factor. But perhaps the most challenging aspect is the sheer remoteness of the abyssal plains. Researchers aren't just battling the physical conditions, they're also working at a profound distance from the human world. Communication between the surface and the deep-sea vehicles is slow and often intermittent. Commands take time to travel, and feedback is delayed. Researchers sitting on a ship miles above the ocean floor can only watch and hope as their machines execute delicate maneuvers far below, often with no guarantee that the equipment will function as expected or return safely. Despite all these obstacles, researchers are driven by a deep sense of wonder and discovery. Every successful mission into the abyss feels like unlocking a secret part of the planet, bringing back pieces of a world that few have ever seen. There's a quiet determination among those who study the deep ocean, a recognition that the challenges they face are simply part of the process. It's not easy, and it never will be. But for those who devote their lives to exploring the abyssal plains, the rewards far outweigh the hardships. They know they're charting some of the last truly unexplored places on Earth, places where the answers to some of our most profound scientific questions might lie waiting, hidden beneath the crushing depths. The abyssal plains are vast, dark expanses covering much of Earth's ocean floor. They stretch out beneath the weight of thousands of meters of water, silent and unknown, untouched by human eyes for millennia. For all the mysteries they hold, they remain one of the least explored realms on the planet. And yet, they pulse with the possibility of discovery. The human drive to understand the unknown compels us to journey down into these depths, to explore not just for knowledge's sake, but for a connection to the deeper forces shaping life, matter, and time. In these lonely, desolate landscapes, scientists believe we may find forms of life unlike anything known. Microbes that subsist on minerals drawn from deep within Earth's crust, forms of chemosynthesis that challenge the very definition of what life requires. As we descend deeper into these regions, we may encounter creatures that have adapted in ways unimaginable, surviving on chemical energy from hydrothermal vents or living under pressures that would crush surface-dwelling organisms. The abyssal plains could unlock the biological keys to survival in extreme environments, illuminating new ways to understand life's tenacity, not just on Earth but perhaps in the far reaches of our galaxy. But beyond life, there's the human fascination with the hidden histories trapped in the abyss. The sediments that cover the abyssal plains are time capsules, layers upon layers of particles that have settled over millions of years. They hold the echoes of ancient climates, past extinctions, and the slow, imperceptible shifts of tectonic plates. By studying these, we may unravel stories of Earth's past climate cycles, events that shaped the planet long before human history began. There is a certain poetry in the thought that, as we dig through these ancient sediments, we are touching remnants of a world unrecognizable to us, while simultaneously grappling with the same forces that may shape our own future. The abyssal plains are also a place where the human relationship with Earth's resources becomes both immediate and complex. Scientists may soon discover rare minerals and metals deep within these plains, materials that could revolutionize technology. Yet, with this discovery comes a question that confronts the human spirit. How do we balance the hunger for progress with the responsibility to preserve the unknown? To harvest these resources would be to disturb a fragile ecosystem that has thrived in isolation, creating a tension between exploration and exploitation. For all the science to be done, there is an emotional and philosophical pull as well. The deeper we go, the more we are forced to confront our own insignificance. The abyssal plains, in their vast emptiness, mirror our internal search for meaning. In the absence of light, warmth, and familiarity, we are stripped of the comforts that keep us anchored, facing instead the awe-inspiring truth that there is so much we do not know. The human experience in the abyss is not just about what we find there, but about how it changes us, how it reshapes our understanding of what it means to live on this planet. Each discovery carries with it the weight of the unknown, but also the promise of wonder, of connections yet to be forged between the deep, the distant, and ourselves. As we resurface from the silent depths, it's clear that the abyssal plains hold more than just the cold and the dark. They are a frontier of life, time, and mystery waiting to be explored. We've only just begun to scratch the surface of what lies below, and the discoveries still to be made could change everything we know about our planet, and perhaps even life itself. Thank you for journeying with me into the unknown. If this dive into the quiet universe stirred your curiosity, be sure to leave a like and subscribe for more voyages into the depths. Together, we'll continue to explore the hidden corners of our world, and maybe, one day, the universe beyond.